Welcome to our cloud computing course. In this course, you will explore the exciting world of cloud technology. Cloud computing is like having a virtual supercomputer that can store data and run programs, making it accessible anytime, anywhere. We will show you how cloud services like Amazon Web Services and Microsoft Azure work and why they are essential for modern businesses. You will learn about the benefits like cost savings and scalability. We'll keep it simple and help you grasp the cloud's power. By the end, you will be ready to harness the cloud for your future success. So, if you are interested in becoming a cloud engineer or architect, then check our Cloud Architect Masters program. Simplilearn's Cloud Architect Certification course will build your AWS, Microsoft Azure, and Google Cloud Platform expertise from the ground up. You will learn to master the architectural principles and services of the top cloud platforms, design and deploy highly scalable, fault-tolerant applications, and develop skills to transform yourself into an AWS and Azure cloud. This program also has Job Assist program. Simplilearn's Job Assist program is an Indian-specific offering in partnership with iimjobs.com to help you land your dream job. To participate in Job Assist program, you need to be graduate in engineering or equivalent or complete our master's program successfully and earn a master's certificate upon completion. So what are you waiting for? Enroll now.
What is cloud computing? As we learn what is cloud computing, we will also be learning about how things were before cloud computing and benefits of cloud computing, different types of cloud computing available, and some of the famous companies that are using cloud computing and they're getting benefited out of it. We're going to learn all that. Before cloud computing existed, if we need any IT servers or application, let's say a basic web server, it does not come easy. Now here is an owner of a business, and I know you would have guessed it already that he's running a successful business by looking at the hot and fresh brewed coffee in his desk and lots of paperwork to review and approve. Now he had a smart, not only smart looking, but a really smart worker in his office called Mark. And on one fine day, he called Mark and said that he would like to do business online. In other words, he would like to take his business online, and for that, he needed his own website as the first thing. And Mark puts all his knowledge together and comes up with this requirement that his boss would need lots of servers, database, and softwares to get his business online, which means a lot of investment. And Mark also adds that his boss will need to invest on acquiring technical expertise to manage the hardware and software that they will be purchasing and also to monitor the infrastructure. And after hearing all this, his boss was close to dropping his plan to go online. But before he made a decision, he chose to check if there are any alternatives where he don't have to spend a lot of money and don't have to spend acquiring technical expertise. Now that's when Mark opened this discussion with his boss, and he explained his boss about cloud computing, and he explained his boss the same thing that I'm going to explain to you in some time now about what is cloud computing. What is cloud computing? Cloud computing is the use of a network of remote servers hosted on the internet to store, manage, and process data rather than having all that locally and using local server for that. Cloud computing is also storing our data in the internet from anywhere and accessing our data from anywhere throughout the internet. And the companies that offer those services are called cloud providers. Cloud computing is also being able to deploy and manage our applications, services, and network throughout the globe and manage them through the web management or configuration portal. In other words, cloud computing service providers give us the ability to manage our applications and services through a global network or internet. Example of such providers are Amazon Web Services and Microsoft Azure. Now that we have known what cloud computing is, let's talk about the benefits of cloud computing. Now I need to tell you, the cloud benefits is what is driving cloud adoption like anything in the recent days. If you want an IT resource or a service now with cloud, it's available for me almost instantaneously, and it's ready for production almost the same time. Now this reduces the go live date and the product and the service hit the market almost instantaneously compared to the legacy environment, and because of this the companies have started to generate revenue almost the next day, if not the same day. Planning and buying the right size hardware has always been a challenge in legacy environment, and if you're not careful when doing this, we might need to live with a hardware that's undersized for the rest of our lives. With cloud, we do not buy any hardware, but we use the hardware and pay for the time we use it. If that hardware does not fit our requirement, release it and start using a better configuration and pay only for the time you use that new and better configuration. In legacy environments, forecasting demand is an full-time job, but with cloud, you can let the monitoring and automation tool to work for you and to rapidly scale up and down the resources based on the need of that hour. Not only that, the resources, services, data can be accessed from anywhere as long as we are connected to the internet. And even there are tools and techniques now available which will let you to work offline and will sync whenever the internet is available. Making sure the data is stored in durable storage and in a secure fashion is the talk of the business, and cloud answers that million-dollar question. With cloud, the data can be stored in a highly durable storage and replicated to multiple regions if you want, and the data that we store is encrypted and secured in a fashion that's beyond what we can imagine in local data centers. Now let's bleed into the discussion about the types of cloud computing. Very lately, there are multiple ways to categorize cloud computing because it's ever growing. Now we have more categories. Out of all these 6 sort of stand out, categorizing cloud based on deployments and categorizing cloud based on services. And again, under deployments, categorizing them based on how they have been implemented. Is it private, is it public, or is it hybrid? And again, categorizing them based on the service it provides. Is it infrastructure as a service, or is it platform as a service, or is it software as a service? Let's look at them one by one. Let's talk about the different types of cloud based on the deployment models first. In public cloud, everything is stored and accessed in and through the internet, and any internet users with proper permissions can be given access to some of the applications and resources. And in public cloud, we literally own nothing, be it the hardware or software. Everything is managed by the provider. AWS, Azure, and Google are some examples of public cloud. Private cloud, on the other hand, with private cloud, the infrastructure is exclusively for a single organization. The organizations can choose to run their own cloud locally or choose to outsource it to a public cloud provider as managed services. And when this is done, the service, the infrastructure will be maintained on a private network. Some examples are VMware Cloud, and some of the AWS products are very good example for private cloud. Hybrid cloud has taken things to the whole new level. With hybrid cloud, we get the benefit of both public and private cloud. Organizations will choose to keep some of their applications locally, and some of the application will be present in the cloud. One good example is NASA. It uses hybrid cloud. It uses private cloud to store sensitive data and uses public cloud to store and share data which are not sensitive or confidential. Let's now discuss about cloud based on service model. The first and the broader category is infrastructure as a service. Here we would rent the service, network, storage, and we'll pay for them in an hourly basis. But we will have access to the resources we provision, and for some we will have root level access as well. EC2 in AWS is a very good example. It's a VM for which we have root level access to the OS and admin access to the hardware. The next type of service model would be platform as a service. Now in this model, the providers will give me a pre-built platform where we can deploy our codes and our applications, and they will be up and running. We only need to manage the codes and not the infrastructure. Here in software as a service, the cloud providers sell the end product, which is a software or an application, and we directly buy the software on a subscription basis. It's not the infra or the platform, but the end product or the software or a functioning application, and we pay for the hours we use the software. And in here, the client maintains full control of the software and does not maintain any equipment. Amazon and Azure also sell products that are software as service. This chart sort of explains the difference between the four models, starting from on-premises to infrastructure as a service to platform as a service to software as a service. This is self-explanatory that the resource managed by us are huge in on-premises, that towards your left as you watch, and it's little less in infrastructure as a service as we move further towards the right, and further reduced in platform as a service, and there's really nothing to manage when it comes to software as a service because we buy the software, not any infrastructure component attached to it. There are lots of famous well-known organizations around the world. They have moved or have migrated to the cloud environment. Pinterest is one company which is one of the world's largest visual bookmarking tool with more than 70 million monthly active users. Now, Pinterest was able to scale its business because it was all built on Amazon Web Services. With a company with less number of employees, Pinterest decided that they do not want to dedicate its staff time to manage a data center. Instead, Pinterest uses AWS, or they used AWS to manage their high performance social application and store more than 8 billion objects and 400 terabytes of data in AWS cloud using a service called Amazon Simple Storage Service, or in short Amazon S3. And not only that, they are running 225,000 instance hours a month, and they run that on Amazon compute service called Amazon EC2 or Amazon Elastic Compute Cloud. Spotify is another company that got benefited using AWS. It's an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify needed a peculiar requirement. It needed a storage solution that could scale very quickly without incurring long lead times for upgrades. Long story short, Spotify used Amazon S3, which is Amazon Simple Storage Service, and Amazon S3 gave them the confidence in their ability and to expand their storage quickly while also providing high data durability. The third biggest company I want to mention is Netflix. It's the world's largest internet television network with more than 100 million members in more than 190 countries. Netflix uses Amazon Web Services for nearly all its computing and storage needs. Now that includes database, analytic, recommendation engines, video transcoding, and a lot more. Not only that, this company is planning to use AWS Lambda to build an automated or an rule-based self-managing infrastructure and replace some of their inefficient process to reduce the rate of errors, and replace inefficient processes to reduce the rate of errors and save their valuable time. Expedia is another famous company that got benefited by using cloud. Expedia provides travel booking service through its flagship site called Expedia.com, and not only that, they also run 200 plus travel booking sites around the world. Expedia is all on AWS, and by using AWS, Expedia has become more resilient with an high scalable infrastructure and better cloud services because it had offloaded the IT management to the cloud provider itself, in this case AWS. And because of this, Expedia's developers have been able to innovate faster while saving the company millions and millions of dollars. We can categorize the different types of cloud computing based on two wide categories, one being a deployment model and the other one being service model. Let's talk about the deployment model first. Deployment model is categorized into three types. First one is public, and then private, and then hybrid cloud. In other words, public cloud, private cloud, and hybrid cloud. It'll be easy for me to explain, and also it'll be easy for you to understand if I walk you through this example. Consider the different types of vehicles we use to commute from one place to another. For example, if I want to travel, I can pick a bus which is accessible to anyone. I get in and I pay for the seat that I occupy, and I pay for the time that I will be traveling in it, and I'm done. Cost is very less here. A similar kind of thing happens in the public cloud. I pay only for the resource that I use, and I pay for how long I use it. If I use less, I pay less. If I use more, I pay more for that month. Simple. On the other hand, private cloud is like buying your own car and using it for commuting purpose. Here, I pay a huge amount upfront and it is all owned only by me. I do not pay for it in an hourly fashion, but completely and all upfront. The cost here is very huge. And thirdly, if I want the best of both types, like the comfort of the own car and still don't want to pay all upfront, otherwise want only to pay for the time that I use the service, I can rent a car. Similarly, I can have it in a hybrid environment, meaning if I already have a DC, I can integrate it with the cloud and use both the DCs, and that would become an hybrid environment. Alright, so that was good of an learning. Let's summarize the types of cloud based on deployment models. And as we know now about the public cloud is an cloud infrastructure that's made available to the general public over the internet, and it is owned by the cloud provider. Some of the major players as cloud providers are AWS, Microsoft Azure, IBM's Blue Cloud, and Sun Cloud. And private cloud? Now this cloud infrastructure is exclusively operated by a single organization. It can be managed by organizations or third party and may exist on premises or off premises, doesn't matter, but the point here is this is exclusively operated for a single organization. And some companies that provide private cloud are AWS and VMware. And hybrid cloud gives the best of both public and the private cloud. For example, the federal agencies, they opt for private clouds for storing and developing personal data, and they use public cloud to share the non-sensitive data with the general public or with other government departments. Now let's talk about different clouds based on the service model. If we need to categorize them broadly, we can categorize them as infrastructure as a service, IaaS, or platform as a service, PaaS, or software as a service, SaaS. They sometimes are referred to as IaaS, PaaS, and SaaS. Now at this moment you could be like this guy thinking, Sam, I thought you're done categorizing the cloud. Now you're going to talk about 3 more categories? Which one should I pick? Well, let me explain. If all that you want is just a VM and you have all the expertise to install the software on top of it and make it work, then go for IaaS. If you only want a platform or an interface to program or an interface to upload a program and make it run, then pick PaaS. Or if all that you want is a finished product hosted in the cloud and be able to access it through the internet, then go for SaaS. Here you get a username and password for an application and you can begin to customize the application based on your needs. Alright, let's talk about IaaS in a bit more detail. IaaS, it gives basic computing infra. It's based on a pay for what you use model. And some of the cloud providers who are big players are AWS, Azure, and Google. And here the users generally will be IT admins. In PaaS, the provider gives you a platform or a runtime environment for developing, testing, and managing application. It's platform ready. You buy the platform, you upload your code, and you start working on it. And it allows the software developers to deploy applications without running the underlying infrastructure. And as you might have guessed by now, the interesting candidates who would use PaaS is software developers. And in SaaS, everything is managed by the vendor, be it the hardware or the software. It's managed by the vendor, and we pay for the service and we pay for it through a pay-as-you-go subscription model. And as you might have guessed, the end users here would be end customer itself. Alright, let's put together everything in the same page and compare and contrast the different types of service models. In this chart, it explains the difference between the 4 models, starting from on-premises to IaaS and then PaaS and SaaS. It is self-explanatory that the resources managed by us are huge in on-premises and little less in IaaS, and further less or reduced in PaaS, and nothing to manage when it comes to SaaS. Let me also explain the different types of cloud services through an example like this. Let's say that you have a crush on cake and you're planning to bake one yourself. Now let's look at the options you can have. You can make all the ingredients yourself, be it the flour, butter, and put together and bake the whole thing yourself using your own oven, pan, the needed water, and the rest. You get an idea, right? Everything is yours, and that's on premises. All that you use is owned by you and nothing is managed by the vendor. The other options you can have is buy the ingredients and mix and bake the cake yourself. Now, this would be like IaaS. Here the infra is managed by the provider and we get to use it and customize it the way we want it. Here the cloud service is a shared responsibility. The other options you still have on hand is simply pick a phone and order a cake. Now this is a lot simpler than the rest we discussed so far. It's simply picking the phone and ordering the cake and pay for it when it arrives. Simple. And when it reaches home, you will have to arrange the table, garnish the cake if that's needed, and then enjoy the cake. It's the same way with PaaS. Just get the platform in which you would run your code and upload your code and start running your application. Here you and the vendor still share the responsibility. You still have one more option left, that is simply go out and dine. This is a lot simpler, that it requires no effort from us at all. You buy the fully finished and garnished cake and pay for it and walk out. No responsibility on making the cake. It's the same way with SaaS. We buy the finished product and pay for the finished application.
Hello everyone and welcome to Simplilearn's YouTube channel. If you have stumbled upon this video, there is a very high probability that you are wondering about how to get a job in the cloud computing domain. And why won't you? The cloud industry is booming with opportunities and it allows everyone to be a part of its growing industry, even for the people with no coding skills. Yes, you heard it right. Even if you don't have extensive coding skills, you can join as a cloud computing professional in some of the top tier product companies. In this video, we will discuss all the nitty-gritty details of how you can get a head start and an entry-level job in the cloud computing domain. So without further ado, let's quickly jump on to the topic.
But wait, to help you with next step, we have our Caltech postgraduate program in cloud computing. This course will help you become an expert in Azure, AWS and GCP and let you master key architectural principles and develop the skills needed to become a cloud expert. This postgraduate program in cloud computing helps you become an expert in designing, planning and scaling cloud implementations. Our cloud computing course helps you master the core skill sets required to design and deploy dynamic scaling and reliable applications. On completion of this course, you will gain Caltech CTME postgraduate certification with 40 plus hands-on projects, along with opportunity to secure a job in large companies like Netflix, MasterCard, Hobby and more. You can check out its link in the description box below. Cloud technology is in high demand and organizations are seeking skilled professionals to manage their cloud infrastructure. This video will guide you through the steps to secure an entry-level cloud job. The first one is gain fundamental knowledge. In that, you to understand cloud implementation in detail. After that, we'll see learn cloud platforms and then start networking and security. The first one is understand cloud computing. Familiarize yourself with the core concepts of cloud computing, including different deployment models like public, private, hybrid, more concepts like service models like LAAS, PaaS and SaaS. Visualization you also have to learn and cloud security. Next we have learn cloud platforms. Focus on popular cloud platforms such as Amazon Web Services, Microsoft Azure and Google Cloud Platform GCP. Start by understanding their basic offerings, features and services. Your next step should be study networking and security. Acquire knowledge of networking fundamentals, TCP/IP protocols, firewalls, load balancing, and network security. This knowledge is crucial for cloud-related roles. The next step is build practical skills. The first one in that is on experience. The next one is work on projects. I will tell you them in detail. The third one is obtain certification. Now, let's see hands-on experience. Create a personal cloud lab using free trial account on platforms like AWS, Azure or GCP. Practice deploying virtual machines, configuring networking and security settings. Experiment with different services and get comfortable with their interfaces. The next one is work on projects. Undertake personal or open source projects that involves cloud technologies. This will provide practical experience and help you showcase your skill to potential employers. Example could include deploying a web application on cloud platform or automating infrastructure. The next one we have obtain certification. Cloud certification demonstrate your expertise and enhance your credibility. Start with entry-level certifications like AWS Certified Cloud Practitioner, Microsoft Azure Fundamentals, or Google Cloud Certified Associate Cloud Engineer. These certifications validate your knowledge and make your resume stand out. Simplilearn also offers cloud certifications that can help you land a good job in this cloud domain. Next, we will discuss networking and professional development. In that, the first one is join online communities. The next one is attend meetups and conferences. And the third one is build a professional online presence. Let's talk about join online communities. Engage with online cloud communities and forums such as Stack Overflow. Participate in discussion, ask questions, and learn from experienced professionals. Networking with like-minded individuals can also lead to a good opportunities. Next we will see is attend meetups and conferences. Attend local tech meetups, cloud conferences, and workshops. These events provide opportunity to networking with industry professionals, learn about latest trends, and gain insights from experts. Be proactive in sharing your knowledge and connecting with potential employers. Next, we will see build a professional online presence. Create a LinkedIn profile highlighting your cloud-related skills, projects, and certifications. Share articles, contribute to relevant communities, and connect with professionals in this field. A strong online presence can attract attention for recruiters and increase your chance of getting noticed. Next, we have job search and preparation. The first step would be refine your resume. The next is practice interviewing and apply for entry-level position. So, how to refine your resume? Tailor your resume and emphasize your cloud-related skills, projects, and certification. Highlight any relevant work experience, internship, or project that demonstrate your understanding of cloud technologies. Next, we have to practice interviewing. So let's see about how to practice interviewing. Prepare for technical interviews by reviewing common cloud-related interview questions and practice responses. Be ready to discuss your hands-on experience, problem-solving abilities, and how you have applied cloud technologies to solve real-world challenges. Next, we have apply for entry-level positions. Search for entry-level cloud jobs opening on online job portals, company websites, and professional network. Apply for positions that match your skill set and career goals. Customize your cover letter for each application, showcasing your enthusiasm for cloud computing and the specific company you are applying to. Continue learning and growth. Cloud technology is constantly evolving. Stay updated with the latest trends, new services, and best practices. Explore advanced certification and consider pursuing higher level cloud roles as you gain experience. Now, securing an entry-level cloud job requires a combination of fundamental knowledge and practical skills, networking, and a proactive approach. By following these steps, continuous learning, and demonstrating your passion for cloud computing, you will increase your chances of landing an entry-level cloud job and kickstart your career in this exciting field.
Snapchat reports that more than 5 billion snaps are generated daily and more than 100 billion messages are sent on WhatsApp daily. Do you ever wonder if storing this data in local storage is possible? The answer is clearly no. According to the projections, by 2025, over 100 zettabytes of data will be stored in the cloud storage. 1 zettabyte is equal to trillion gigabytes. Now imagine the amount of data the world generates and how it is being managed. So cloud experts are responsible for this smooth transition. Google Workspace has already surpassed the mark of 2 billion users in 2020, and 60% of the total corporate data is already present in the cloud. So these stats are enough to let anyone know where this technology is headed and what wonders are awaiting in cloud computing. Tech giants like Google, Amazon, and Microsoft are trying to conquer this exponentially growing market with their products like Amazon Web Services, Google Cloud Platform, and Microsoft Azure. Furthermore, in this fast-paced world, a job in this field is more than worth it. The salaries offered in this field are very lucrative and fascinating. Among all the job roles currently available in cloud computing, a cloud architect in India earns an average salary of 20 lakhs per annum, and in the United States, it goes around $125,000. So these figures are stated by Glassdoor.com and show how beneficial it is to bag a job in this sector today. But the fact is, nothing comes easy. So we at Simplilearn will save some of your time and let you know about the process of how to become a cloud expert in 2023. We'll take you through the complete cloud computing roadmap. But before we begin, if you enjoy watching these videos and find them interesting, please subscribe to our channel because we bring the best videos for you daily. Also, hit the bell icon to get notified whenever we drop a new video. So without any further delay, let's go through the agenda for today's video.
This video will provide all the vital information about cloud computing. We'll start this video with an introduction to cloud computing. Following that, we'll take you through the skills to become a successful cloud expert. We'll then take you through the steps you can take to become a cloud engineer. And finally, we'll explore some of the potential roles and growth opportunities in the field of cloud computing. So let's start this video with what is cloud computing. Cloud computing in simple terms refers to the practice of using remote servers on the internet to store, manage and process data instead of relying on your local computer. It allows you to access your files, applications and services from anywhere with an active internet connection, providing convenience, scalability and flexibility for individuals and businesses alike. A number of skills are required to become a master in the field of cloud computing. The first one is technical skills. Cloud engineers should have a strong foundation in areas such as networking, operating systems, and programming languages. They should be familiar with cloud platforms like Amazon Web Services, Microsoft Azure, or Google Cloud Platform. Problem-solving abilities. Cloud engineers often encounter complex technical challenges. Developing strong problem-solving and troubleshooting skills is crucial to identify and resolve issues efficiently. Security and compliance knowledge. Cloud engineers must understand security practices, data privacy regulations, and compliance standards. They need to protect sensitive data and maintain compliance with industry regulations. Continuous learning. Cloud technology evolves rapidly, so it's essential for cloud engineers to have a thirst for learning. Keeping up with the latest trends, attending training programs, and obtaining relevant certifications will help you stay ahead. Now that we have a grasp of the skills required, let's discuss the steps you can take to become a cloud engineer. Get familiar with cloud concepts. Start by gaining a basic understanding of cloud computing concepts. Familiarize yourself with the advantages, different service models such as infrastructure as a service, platform as a service, and software as a service, and deployment models like public, private, and hybrid. Second is learn cloud platforms and technologies. Choose a cloud platform to specialize in, such as AWS, Azure, or GCP. Explore their documentation, online tutorials and resources to understand their offerings, services, and tools. Gain hands-on experience by experimenting with the platforms and building simple projects. Acquiring relevant certifications. Cloud certifications validate your skills and demonstrate your expertise to potential employers. Consider pursuing certifications such as AWS Certified Cloud Practitioner, Azure Fundamentals, or Google Cloud Certified Associate.
Design of business processes in the cloud. They're also involved with a number of different tasks like optimizing efficiency and performance, scaling application components, and security issues. Now let's have a look at some of the skills required to become a cloud application developer. First off, you need to have experience with database languages like MySQL, SQL, and MongoDB. Then you need to have experience with programming languages like Python, Ruby, and Perl so that you can code and create cloud computing applications. You'll also need to have experience with Linux. Now this is because most cloud infrastructures are created with Linux servers. You'll also need to have experience with cloud service providers like Amazon Web Services, Google Cloud Platform, and Microsoft Azure. You'll need to have experience with information security with the help of certifications. You'll also need to know how to create microservices and to create cloud applications. Now let's have a look at the salary offered to a cloud application developer. In the United States, it's approximately $70,000 per annum. In India, the average salary of a cloud application developer is approximately 8 lakh rupees per annum. Now, let's have a look at some of the companies hiring cloud application developers. You have companies like Bosch, McAfee, SAP, and so on. So now let's go to number 5, Cloud Network Engineer. A cloud network engineer is responsible for implementing, supporting, maintaining, and optimizing the network hardware, software, and communication links of the organization's cloud infrastructure. He or she basically focuses on automation and security while building the cloud infrastructure, enhancing network tooling visibility, and improving productivity. Now let's have a look at some of the skills required to become a cloud network engineer. First off, obviously, you need to have experience with networking, which means a familiarity with the internet and WAN communication technologies, protocols, and best practices. You need to have an understanding of cloud security and how you can design a public cloud with multiple options. You'll need to have an experience with data center administration, which basically means an understanding on infrastructure design, operations, and lifecycle management. And finally, you need to have experience with cloud computing platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Next, let's have a look at the salaries offered to a cloud network engineer. Firstly, the average salary of a cloud network engineer in the United States is approximately $72,000 per annum. In India, the average salary of a cloud network engineer is approximately 4 lakh rupees per annum. Now that we're done with this, let's have a look at the companies hiring cloud network engineers. We have companies like Amazon Web Services, Rakuten, Cisco, and so much more. Now for number 4, we have Cloud Automation Engineer. A Cloud Automation Engineer focuses on cloud automation, orchestration, and integration. He or she implements, optimizes, and supports the cloud infrastructure and ensures it has high availability. They also have to increase the cost effectiveness and availability of the cloud. Now let's have a look at some of the skills required to become a Cloud Automation Engineer. First off, since the role is cloud-based, experience with a cloud service platform like Microsoft Azure, AWS, or Google Cloud Platform is an absolute must. You'll also need to have experience with programming languages like Python and Go that will help you make the process of automation easier. Next, experience with DevOps tools like Chef, Ansible, and Puppet are seen as a huge plus. You'll also need to have an understanding of Docker and containers. Experience with databases like PostgreSQL and MySQL that can handle multiple workloads would be very useful. And finally, you need to have experience with virtualization, which means you need to know how you can work with virtual servers, applications, storage, and networks. With this, you can reduce the amount of resources required by the organization. Now, let's have a look at the salary offered to cloud automation engineers. In the United States, the average salary of a cloud automation engineer is approximately $79,000 per annum. The average salary of a cloud automation engineer in India is approximately 5 lakh rupees per annum. Now that we're done, let's have a look at some of the companies hiring cloud automation engineers. We have companies like Oracle, Google, Capgemini, Disney, and so on. And now to number 3, Cloud Security Manager. A cloud security manager is someone who is responsible for providing security for cloud-based digital platforms and protecting the organization's data. He or she may be involved with creating new security methods or to analyze existing ones. They may also have to create cloud-based applications, performing threat simulations, and providing security recommendations. Now, let's have a look at some of the skills required to become a cloud security manager. First off, you'll need to have experience with at least one of the popular cloud service providers like Amazon Web Services, Microsoft Azure, and GCP. You'll also need to have experience in programming languages like Python. Experience with commonly used DevOps tools like Jenkins so that you can implement continuous integration or continuous deployment models would be very helpful. You'll also need to be well versed with TCP/IP protocols and other networking concepts. You need to be well versed with PKI, SSL, SSH, HTTPS, and so on. Experience with web-based analytics and services would also be very helpful. Now let's have a look at the salary offered to a cloud security manager. In the United States, the average salary of a cloud security manager is approximately $99,000 per annum. In India, the average salary for cloud security manager is approximately 11 lakh rupees per annum. Now let's have a look at some of the companies hiring cloud security managers. We have companies like Deloitte, VMware, Cisco, Dell, and so on. Now let's move on to number 2, Cloud Engineer. A cloud engineer is an individual who is responsible for any technological duties that are associated with cloud computing, including design, planning, management, maintenance, and support. They are also involved with orchestrating and automating cloud-based platforms throughout the organization. Let's have a look at the skills required to become a cloud engineer. First off, you'll need to have experience with at least one of the popular cloud service providers like AWS, Microsoft Azure, or the Google Cloud Platform. You'll need to have an understanding of networking concepts like building and accessing servers, virtual networks, and so on. This enables cloud engineers to make sure that the network is responsive to the users. Next, you need to have experience with virtualization. With virtualization, you can reduce how many hardware units you need with the help of virtual machines. It also makes resources scalable and fault tolerant in an organization. Experience with the Linux operating system would also be very helpful, considering how 30% of the servers that power Azure are Linux based. You'll need to know about APIs to design RESTful services. Experience with DevOps is also a major skill to have, since it'll be able to help handle work dependencies between the development and operation teams. And finally, you need to have programming experience with languages like Java, Python, C++, and Ruby. Next, let's have a look at the salary offered to a cloud engineer. In the United States, the average salary of a cloud engineer is approximately $105,000 per annum. The average salary in India is approximately 5 lakh rupees per annum. Now, let's have a look at some of the companies hiring cloud engineers. We have companies like McAfee, IBM, JP Morgan, Visa, and so on. Now, I see a pretty good question in the chat. How do you become a cloud engineer? So, to become a cloud engineer, you need to have experience with the programming language, experience with at least one cloud service platform, which is Amazon Web Services or Microsoft Azure or Google Cloud Platform. The choice is yours. And you need to specialize in a particular service, be it storage and networking, disaster recovery, and so on. And now for number 1, Cloud Architect. A cloud architect is responsible for managing cloud computing architecture in an organization. He or she handles everything to do with front-end platforms, servers, storage, delivery, and networks. Now, let's have a look at some of the skills required to become a cloud architect. First off, you need to have knowledge in programming. Knowledge about Perl, Python, Ruby, PHP, Java, and .NET can provide users with the ability to build, deploy, and manage applications quickly. You'll need to know about the basics of networking. Since most of the work what you'll be doing would be web related, knowledge about networking can be really helpful. Knowledge about data storage fundamentals are also really important. This provides you with the knowledge to determine which data storage option to use and when. Being experienced with cloud service platforms is also really important. Platforms like AWS, Google Cloud Platform, and Microsoft Azure are what you are going to be basing most of your work on. Experience with them is pretty important. And finally, cloud security. This will help you make sure that your data is secure and only authorized code is run and the right people are allowed to run it. Now, let's talk about the salary of a cloud architect. The average salary of a cloud architect is approximately $107,000 per annum. In India, the average salary of a cloud architect is approximately 16 lakh rupees per annum. And there you go. Those are the top job roles in the field of cloud computing. Now let's have a look at some of the companies hiring cloud architects. We have companies like EY, Wipro, Huawei, Hewlett-Packard Enterprise, and so on.
Hello everyone, let me introduce myself as Sam, a multi-platform cloud architect and trainer, and I'm so glad and I'm equally excited to talk and walk you through this session about what AWS is and talk to you about some services and offerings and about how companies get benefited by migrating their applications and infra into AWS. So what's AWS? Let's talk about that. Now, before that, let's talk about how life was without any cloud provider, and in this case, how life was without AWS. So let's walk back and picture how things were back in 2000, which is not so long ago, but a lot of changes for better had happened since that time. Now, back in 2000, a request for a new server is not an happy thing at all, because a lot of money, a lot of validations, a lot of planning are involved in getting a server online or up and running. And even after we finally got the server, it's not all said and done. There's a lot of optimization that needs to be done on that server to make it worth it and get a good return on investment from that server. And even after we have optimized for a good return on investment, the work is still not done. There will often be a frequent increase increase and decrease in the capacity. And even news about our website getting popular and getting more hits, it's still an bittersweet experience, because now I need to add more servers to the environment, which means that it's going to cost me even more. But thanks to the present day cloud technology, if the same situation were to happen today, my new server, it's almost ready, and it's ready instantaneously. And with the swift tools and technologies that Amazon is providing in provisioning my server instantaneously and adding any type of workload on top of it and making my storage and server secure, creating a durable storage where data that I store in the cloud never gets lost, with all that features, Amazon has got our back. So let's talk about what is AWS. There are a lot of definitions for it, but I'm going to put together a simple and a precise definition as much as possible. Now, let me iron that out. Cloud still runs on an hardware, right? And there are certain features in that infrastructure, in that cloud infrastructure, that makes cloud, or that makes AWS a cloud provider. Now, we get all the services, all the technologies, all the features, and all the benefits that we get in our local data center, like, security and compute capacity and databases. And in fact, we get even more cool features like content caching in various global locations around the planet. But again, out of all the features, the best part is that we get everything on a pay-as-we-go model. The less I use, the less I pay, and the more I use, the less I pay per unit. Very attractive, isn't it? Right? And that's not all. The applications that we provision in AWS are very reliable because they run on a reliable infrastructure, and it's very scalable because it runs on an on-demand infrastructure, and it's very flexible because of the designs and because of the design options available for me in the cloud. Let's talk about how all this happened. AWS was launched in 2002 after the Amazon, we know as the online retail store, wanted to sell their remaining or unused infrastructure as a service or as an offering for customers to buy and use it from them, sell infrastructure as a service. The idea sort of clicked, and AWS launched their first product in 2006. That's like 4 years after the idea launch. And in 2012, they held a big-sized customer event to gather inputs and concerns from customers, and they were very dedicated in making those requests happen. And that habit is still being followed. It's still being followed as reInvent by AWS. And at 2015, Amazon announced its revenue to be 4.6 billion. And in 2015 through 2016, AWS launched products and services that help migrate customer services into AWS. Well, there were products even before, but this is when a lot of focus was given on developing migrating services. And in the same year, that's in 2016, Amazon's revenue was 10 billion. And not the least, as we speak, Amazon has more than 100 products and services available for customers and get benefited from. Alright, let's talk about the services that are available in Amazon. Let's start with this product called S3. Now, S3 is a great tool for internet backup, and it's the cheapest storage option in the object storage category. And not only that, the data that we put in S3 is retrievable from the internet. S3 is really cool. And we have other products like migration and data collection and data transfer products. And here we can not only collect data seamlessly, but also in a real-time way monitor the data or analyze the data that's being received. That there are cool products like AWS data transfers available that helps achieve that. And then we have products like EC2, Elastic Compute Cloud. That's an resizable computer where we can anytime alter the size of the computer based on the need or based on the forecast. Then we have simple notification services, systems and tools available in Amazon to update us with notifications through email or through SMS. Now anything can be sent through email or through SMS if we use that service. It could be alarms or it could be service notifications if you want, stuff like that. And then we have some security tools like KMS, Key Management System, which uses AES 256-bit encryption to encrypt our data at rest. Then we have Lambda, a service for which we pay only for the time in seconds it takes to execute our code, and we're not paying for the infrastructure here. It's just the seconds the program is going to take to execute the code. If it's a short program, we'll be paying in milliseconds. If it's a bit bigger program, we'll be probably paying in 60 seconds or 120 seconds. But that's lot cheap, lot simple, and lots cost effective as against paying for service on an hourly basis, which a lot of other services are. Well, that's cheap, but using Lambda is a lot cheaper than that. And then we have services like Route 53, a DNS service in the cloud. And now I do not have to maintain an DNS account somewhere else and my cloud environment with AWS. I can get both in the same place. Alright, let me talk to you about how AWS makes life easier, or how companies got benefited by using AWS as their IT provider for their applications or for the infrastructure. Now, Unilever is a company, and they had a problem, right? And they had a problem, and they picked AWS as a solution to their problem, right? Now, this company was sort of spread across 190 countries, and they were relying on a lot of digital marketing for promoting their products. And their existing environment, their legacy local environment, proved not to support their changing IT demands, and they could not standardize their old environment. Now, they chose to move part of their applications to AWS because they were not getting what they wanted in their local environment. And since then, rollouts were easy, provisioning new applications became easy, and even provisioning infrastructure became easy, and they were able to do all that in push button scaling. And needless to talk about backups that are safe and backups that can be securely accessed from the cloud as needed. Now, that company is growing along with AWS because of their swift speed in rolling out deployments and being able to access secure backups from various places and generate reports, and in fact useful reports out of it that helps their business. Now, on the same lines, let me also talk to you about Kellogg's and how they got benefited by using Amazon. Now, Kellogg's had a different problem. It's one of its kind. Now, their business model was very dependent on an infra that will help to analyze data really fast, right? Because they were running promotions based on the analyzed data that they get. So they being able to respond to the analyzed data as soon as possible was critical or vital in their environment. And luckily, SAP running on HANA environment is what they needed, and they picked that service in the cloud, and that sort of solved the problem. Now, the company does not have to deal with maintaining their legacy infra and maintaining their heavy compute capacity and maintaining their database locally. All that is now moved to the cloud, or they are using cloud as their IT service provider, and now they have a greater and powerful IT environment that very much complements their business.
So if you are interested in becoming a cloud engineer or architect, then check our Cloud Architect Masters program. Simplilearn's Cloud Architect certification course will build your AWS, Microsoft Azure, and Google Cloud Platform expertise from the ground up. You will learn to master the architectural principles and services of the top cloud platforms, design and deploy highly scalable, fault-tolerant applications, and develop skills to transform yourself into an AWS and Azure cloud. This program also has Job Assist program. Simplilearn's Job Assist program is an Indian-specific offering in partnership with iimjobs.com to help you land your dream job. To participate in Job Assist program, you need to be graduate in engineering or equivalent, or complete our master's program successfully and earn a master's certificate upon completion. So what are you waiting for? Enroll now.
Hi there, I'm Samuel, a multi-platform cloud architect, and I'm very excited and honored to walk you through this learning series about AWS. Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers, but prior to AWS, they had some issues. Imagine using using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital cost. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service. Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL, or American Online, uses AWS, and using AWS they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy to use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code and Elastic Beanstalk automatically handles the deployment from capacity provisioning provisioning to load balancing to auto scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic load balancing, it's also a network and content delivery service. Elastic load balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone and also across availability zones. AWS auto scaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS auto scaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Auto scaling can be applied to web services and also for DB services. AWS identity and access management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy a web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage. And S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment. And CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG signup, and the environment name is GSG signup environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well. And it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? All right, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. All right, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL.
Without further ado, let's dive headfirst. And before that, if you are one of the aspiring cloud enthusiasts looking for online training and graduating from the best universities, or a professional who elicits to switch careers in cloud computing by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in cloud computing in collaboration with Caltech Center for Technology and Management Education. The course link is mentioned in the description box that will navigate you to the course page, where you can find a complete overview of the program being offered. So let's dive right in the details and explore the magic behind AWS step functions. So the first thing we will explore is understanding the AWS step function challenges. So before we get into the specifics of AWS step functions, let's understand the problem it addresses. As you build larger applications with many different parts, managing and coordinating them can become quite tricky. Absolutely. Imagine you have a bunch of different tasks that need to happen in a specific order to complete a big project. For example, if you want to build a house, you need to follow a specific sequence of steps like laying the foundation, building the walls, putting on the roof, and so on. But what if something goes wrong in the middle of the process? Like the wall building part doesn't work correctly or you run out of bricks. That's where the challenge lies. With traditional methods, handling these errors and coordinating everything can become a nightmare. And here comes the AWS step functions. Now we'll have an introduction to AWS step functions. So here AWS step function comes to rescue with these challenges. So AWS step functions are like having a master conductor who organizes and orchestrates all the tasks in your application. It helps you build workflows as a series of steps or tasks, making it easier to manage the entire process. That's right, just like a conductor guides the musicians in an orchestra to play their instruments at the right time, AWS step functions guides you different services and functions to work together harmoniously. It does this by using something called state machines. So a state machine is like a big map that shows all the different steps your application needs to take to finish its work. Each step in the state machine is a specific task that your application needs to do. It could be running a piece of code, processing some data, or even making decisions based on certain conditions. And now we'll see the components of AWS step functions. Now that we have basic understanding, let's talk about the key components of AWS step functions. The first and most important component is the state. Each state represents a single task or a step in your workflow. And there are different types of states like task, choice, and parallel. A task state does a specific job like running a lambda function or an activity. A choice state makes decisions based on conditions, and a parallel state lets you do multiple tasks at once. That's right. And what's really cool is that AWS Step Functions automatically manages the flow between these states. It makes sure that each task happens in the right order, just like following the steps to build a house. And here's the best part. If something goes wrong during one of the tasks, AWS Step Functions can handle it. It can retry the task a few times or even go to different part of the workflow to deal with the problem. And now you can see the state machine diagram on the screen. So this state machine starts with the start state, which represents the beginning of the workflow. From the start state, it goes to the check item stock, that is a state, which is a task state that checks if the requested item is available in the store's inventory. After completing the check item stock task, the state machine proceeds to process payment state, another task state that processes the customer's payment based on their chosen payment method. The notify method state is a choice state that evaluates whether the customer prefers to be notified via email or SMS. If the customer prefers email, the state machine goes to notify customer email state, which is a task state that sends an order confirmation email to the customer. If the customer prefers SMS, the state machine goes to notify customer SMS state, which is another task state that sends an order confirmation SMS to the customer. The parallel state is responsible for running both notify customer email and notify customer SMS tasks simultaneously. Once the tasks in the parallel state are completed, the state machine reaches the end state, which marks the end of the workflow. The visual representation of the state machine provides a clear overview of how AWS Step Functions coordinate in the different tasks and branches in the workflow. It helps in understanding the flow and logic of the serverless application and enables developers to manage and modify the workflow efficiently. And now we'll see how AWS Step Functions work. And now let's see how they will work. Imagine you are a chef and you want to bake a cake. You have different steps like mixing the ingredients, putting the batter in the oven, and decorating the cake. With AWS Step Functions, you can define a state machine for baking a cake. The state machine will list all these steps and the order they need to happen in. So when you start the state machine, it will take you through each step one by one, just like following a recipe. And if you accidentally put too much sugar in the batter, AWS Step Functions can handle that. It can go back and give you another chance to mix the right amount of sugar. Or if the oven suddenly stops working, AWS Step Functions can pause the baking process and wait for the oven to be fixed before continuing. And now we'll see the benefits of AWS Step Functions. AWS Step Functions offer several benefits. Let's highlight a few of them. First, they make your application more reliable. With built-in error handling and automatic retries, you can be confident that your workflows will work smoothly even if something goes wrong. Absolutely. And AWS Step Functions also make your life as a developer easier. The visual workflow designer in the AWS Management Console allows you to see and modify your workflows graphically. Plus, it's highly scalable. As your application grows, AWS Step Functions can handle more and more complex workflows without a hitch. And let's not forget about cost effectiveness. You only pay for the state transitions and the time your workflows are running, which means you can save money while building powerful applications. So these were the benefits of AWS Step Functions. Now we'll see the real-world use cases. AWS Step Functions are incredibly versatile and can be used in many real-world scenarios. For example, if you have a big online store, you can use AWS Step Functions to handle the entire order process, from receiving the order to receiving the payment, checking the inventory, and finally shipping the products. And let's not forget about data processing. AWS Step Functions are perfect for automating data pipelines, where you need to extract, transform, and load data from one place to another. It's also a great tool for managing microservices. If you have different parts of your application running independently, AWS Step Functions can help you coordinate their interactions. And now we conclude this topic, that is AWS Step Functions. So to wrap things up, AWS Step Functions are like having a magical conductor for your applications. They make it easier to manage and coordinate all the different tasks in your serverless workflows. With AWS Step Functions, you get reliability, simplicity, scalability, and cost effectiveness all in one package. So if you are working on AWS and want to simplify your serverless architecture, give AWS step functions a try. And now let's take a minute to hear from our learners who have experienced massive success in their careers.
I will be permanently moving to Europe with my family soon. Simplilearn course has helped me back a great job offer there with 60% salary hike. We cannot wait to start our new life in Finland. We are all so excited. Hey, I am Salahuddin Quadra and I am currently living in Algeria. I am working as Chief Information Technology Officer at Iris Tires. After working for 23 years in IT sector in Algeria, I felt that my career had become stagnant here. I wanted to experience what it's like to live in Europe, so I started applying to various jobs there. As someone who is responsible for making a decision, I wanted to upgrade my skills. I also realized that to get a new job, I needed to have a professional certification in cloud computing. So last year, I started the postgraduate program in cloud computing in association with Caltech from Simplilearn. It's not easy to get access to Caltech, but Simplilearn provided that with this course, I had the choice to study while I continued with my job. I learned technologies like AWS and Azure during the course. Luckily, my new employers were looking for someone who knew these technologies. I have just completed the course, but my new employers were aware that I was taking this course. And that is how I got this new job offer with 60% salary hike. In Finland, I will be leading the cloud computing unit of my new company. I am really excited, not just for myself, but for my family as well. I have 3 daughters. I think I will be able to help them with their higher studies in Europe. As a father, you always want to make decisions that have a positive impact on your children. As for me, I am going to live my dream now. I think dreams come true when you work hard to achieve them.
Welcome to this video about AWS Bedrock. If you are new to cloud or looking to get up to the speed on AWS, this is the perfect place to start. AWS Bedrock is a foundation considering of a set of AWS services that can be used to build reusable and scalable applications. In this video, we will cover what AWS Bedrock consists of and why it's important to use it. Whether you are a seasoned developer or just getting started, you will learn about AWS Bedrock in just a minute. So let's dive in. But before that, cloud computing is a highly technical field and having a right certification can set you apart from the competition. Consider getting certified in popular cloud computing platforms like AWS, Azure or Google Cloud. Now to help you with this step, we have our Caltech postgraduate program in cloud computing. This course will help you become an expert in Azure, AWS and GCP and let you master fundamental architecture principles and develop the skills needed to become a cloud expert. This postgraduate program in cloud computing will help you become an expert in designing, planning and scaling cloud implementations. After completing this course, you will gain Caltech CTME postgraduate certificate with 40 plus hands-on projects. You can check out its link in the description box below.
Hey, I am Salahuddin Quadra and I am currently living in Algeria. I wanted to experience what it's like to live. I also realized that to get a new job, I needed to have a professional certification in cloud computing. So last year, I started the postgraduate program in cloud computing in association with Caltech. With this course, I had the choice to study while I continued, and that is how I got this new job offer with 60% salary hike. In Finland, I will be leading the cloud computing unit of my new company. We cannot wait to start our new life in Finland. We are all so excited.
Now, let's see the agenda for this video.
In this video, we will see what is Amazon Bedrock. After that, we will see what can Amazon Bedrock do. Moving ahead, we will see what is a foundational model. And then, we will see the use cases of AWS Bedrock and conclude this video. So, there is no doubt that major tech companies are actively competing to gain a significant share of a rapidly expanding artificial intelligence market. The release of OpenAI revolutionary ChatGPT service has further intensified this race, capturing the both interest of IT and non-IT professionals. According to various reports, the IT industry is predicted to survey to a value of $90 billion or more than that by 2025. Now, let's see what is Amazon Bedrock. Amazon Bedrock is a recently launched machine learning platform by Amazon Web Services that provides users with a convinced way to build and expand AI application using foundational model, also known as FMS. This platform greatly accelerates the development process by leveraging foundational model without the need of handle physical infrastructure or the associated operational complexities. Also, users have the flexibility to choose from a variety of foundational models, including those offered by AI21 Labs, Anthropic, or internally by AWS. Additionally, organizations can customize these foundation models using their own data and utilize familiar AWS tools and capabilities, ensuring the development of scalable and highly secure generative AI applications. Now, let's see what Amazon Bedrock can do. Amazon Bedrock, a user-friendly machine learning platform similar to Amazon SageMaker, enables the building and scaling of a generative AI application using foundational model. Unlike the SageMaker, which ML engineers primarily use for custom model development, Bedrock focuses on leveraging FMS for ease of use. Now you must be thinking what FM is. Now let's see what is a foundation model. Foundational models, also known as FMS, are models that are trained on diverse data and can be adapted by multiple downstream tasks. Unlike high learning models designed for specific use cases, foundational models serve as a foundation that can be utilized across various applications. Instead of investing extensive time and resources into training separate custom models for specific tasks, the focus is on the building adaptable and versatile model capable of performing multiple functions. This approach promotes efficiency by creating a model that can handle various tasks rather than a specified model limited to a single process. Now, you must have gotten the idea what foundational model is. Now, let's see the use cases of Amazon Bedrock. Text generation. It enables the generation of originally written content such as short stories, social media posts, articles, web page copy, and even school essays. Now we have chatbots. Bedrock facilitates the creation of conventional interfaces like chatbots and virtual assistants. To ensure user experience, integration with Amazon Lex, AWS chatbot services may be possible. Next we have search. In search, user can easily search, find, and get the information from a diverse data sources, allowing various questions. Moving ahead, we have text summarization. This platform offers the capability to summarize text content from sources like blog posts, essays, books, and documents, providing conscious summaries without the need for lengthy reading. Next, we have image generation. Amazon Bedrock can generate realistic and artistic image based on specific subject, environment, and scenes. Next, we have personalization. The platform's AI service enables personalized customer interaction, allowing users to search for exactly what they are looking for with the relevant product key recommendations. Now, Amazon Bedrock empowers users to build and scale generative AI applications for tasks such as text generation, chatbots, search and text summarization, image generation, and personalization of approach to leveraging foundational models. Now, in conclusion, Amazon Bedrock is a powerful machine learning platform offered by AWS, allowing users to build and scale generative AI applications using foundational model. With the rapid growth of the AI market, Amazon Bedrock positions itself as a valuable tool for organizations looking to of generative AI without the complexities of custom model development. By leveraging foundational model, user can unlock the potential of AI in areas such as text generation, chatbots, search, summarization, image generation, and personalization, driving innovation and ensuring user experience.
Welcome to the realm of cutting edge technology. Have you ever wondered what it would like to harness the immense power of Google's computing infrastructure right at your fingertips? Look no further, for in digital realm that there exists a phenomenon known as Google Collab, an interesting fusion of cloud computing and collaborative prowess. Imagine a world where you can effortlessly explore the limitless possibilities of artificial intelligence, machine learning, and data analysis without the need for expensive hardware or complex setups. Google Collab emerges as Celestial Sanctuary, offering you a virtual laboratory to experiment, create, and collaborate with like-minded enthusiasts from every corner of the globe. In this exciting video, we will understand what is Google Collab, and then we will have a complete overview of it. So let's start with the first topic. What is Google Collab? So Google Collab is a free online tool that lets you do coding and data related work on the internet. It's like having a virtual notebook where you can write and run Python code without needing to install anything on your computer. With Collab, you can also get data from different places and share your work with others easily. Another cool thing is that it gives you access to powerful processors like GPUs and TPUs, which make tasks like machine learning and data science faster and more efficient. So it's a great tool for learning and working on coding and data projects. Alright, now let's have a look at Google Collab. Let's have a complete overview of it. So first of all, Google Collab requires a Google account for access. To begin, visit the link Welcome to Collaboratory. Right, Welcome to Collaboratory, as you can see. We'll click on this. Then we'll click on this, open this one, and sign in using our Google account or credentials. If you already have a Google account, then you can just sign in with that. Alright, now let's start with the Google Collab. We'll simply write Google Collab. We'll click on this. Alright, so this is the window that appears when you click on that. First of all, here we have is Example tab. So the Example tab offers some initial examples to help you begin using Collab. For a comprehensive understanding of collaborative features and efficient usage of Collab documents, refer to the document titled Overview of Collaborative Features. It covers the fundamental aspects to get you started efficiently. Then there is Recent tab. Alright, so the Recent tab displays a collection of all the latest documents you have been working on. Alright, now next is our Google Drive tab. The Google Drive tab features allows you to import any of your previous notebooks directly from your Google Drive. Alright, then next is GitHub tab. So with the GitHub tab, you have the option to import notebooks from your own GitHub repository or any public repository. Simply provide the GitHub URL and you can easily import notebooks from the desired public repository. Then we have is Upload tab. So the upload feature allows you to bring and work on your own Jupyter notebooks that you have created on your computer. You can easily upload any file from your local machine by selecting the Choose File option. Here it is, Choose File option. Now next is our Creating a Notebook. As we can see, here's a New Notebook option and there's a Cancel option. So creating a notebook. So to create a new notebook, you have the option to use the New Notebook button located at the bottom. By clicking on this button, a new untitled notebook will be generated. To give it a specific name, and simply click on the current untitled name if we want to name it. So as we have clicked on it, to give it a specific name, as we just said, simply click on the current untitled name on the notebook and make the desired changes. So let's say we want to make it SP1. Let's just say it a name. Alright. So next is our cell. Here we can see this is a cell. In a notebook, cells serve as the fundamental building blocks, encompassing everything within. There are two types of cells actually. One is code cell, as you can see. It contains executable code and has a run button on the left side to execute its content. This one. Alright. The output is displayed, its output is displayed below the code cell after running. Right. Then the next one is, other one is text cell. So a text cell can include text, images, links and more. You can edit its content by double clicking it. The text cell supports markdown markup language, but you can also use the provided options on the top for formatting. The right half of the cell shows you how your edited text will appear. Alright, now the next point would be adding a new cell, like how to add a new cell. To add a new code or text cell, use the respective option at the top of the work area. As you can see, these code or text, by clicking on these we can add code cell and text cell. So clicking on any of these buttons creates a new cell right below the current one. You can, like, let's say we want to add this, so now we want to add this, we can add this also. Now you can rearrange the cell order using the arrow options located at the top right corner of each cell. As you can see, by using these we can do that. Yeah, the up arrow moves the cell one position up, while the down arrow moves it down by one position. As we can see. Now adding and running a code. Let's talk about this. So by default, Google Colab provides one initial code cell which can be supplemented with additional cells as desired. These cells serve as a platform for writing and executing Python code. For instance, let's consider the following code. Let's say, first of all, let us delete all these. This one also. Yeah. So first of all, we'll try one code. Let's see how it goes. So I'll simply write the code print my favorite color is yellow. Alright, so now let's try to execute it. We can run it by clicking on this. It is running, executing. So as you can see, my favorite color is yellow is being printed. So you can either press on this play button to run the code, or you can press Ctrl plus enter to run the code. As you can see, Ctrl plus enter to run the cell. Now next is changing the order of the cell. So in Google Colab, you have multiple options for rearranging cells. You can utilize the up cell and down cell buttons located in the toolbar above the notebook, as we discussed previously. Alternatively, you can employ keyboard shortcuts such as Ctrl Shift up or Ctrl Shift down to move the chosen cell up or down. Additionally, you have the flexibility to reorder cells by clicking on the cell number in the left gutter and dragging it to a different position. Alright, now deleting the current tab. So to delete the current tab in Google Colab, you can use the delete icon available over the top of the cell. This icon looks like a trash can and it will remove the selected cell from the notebook. As we can see, this is the trash can and this is just at the right above corner of the cell. By clicking on this, we can delete the tab. Alternately, you can also use the keyboard shortcut Ctrl plus M and D to delete the current cell. You can also right click on the cell and select delete cells from the context menu. As you can see, delete cell. Alright, now we will understand how to add datasets. So to add datasets from your local device, go to the left corner and click on the folder icon. As we can see, this is the left corner and this is the folder icon. We'll click on that. Now click on the upload icon and upload the desired file. This is the upload icon. We'll click on that. Now we can upload the desired file, whichever we want. Alright. You can also upload files by writing a particular command. Let's try writing that command, okay? So we'll write from google.colab import files. Let's import files. Alright. After that we'll write upload equals files dot upload. After that we'll put on brackets. Alright, now we'll press Ctrl and enter, and here we can see choose files. Now from here you can choose files, so both the ways you can upload files, I'm just telling. Now let's understand how to import libraries in Google Collab. So first of all, we have to cancel upload. We'll click on this. Alright. So to import it, we'll write import pandas as pd. Alright, after that we'll write pd.read. So here we are importing the CSV files actually. So we have to write like pd.read underscore CSV, and inside this we'll write a file. Let's say we have to check what all files, like this is the sample data files, right? So you have to write the file name actually which you want to import, that CSV file name. I'm writing sample underscore data. Alright, underscore test. The location you have to put .csv. So this is the location. Alright, so if we want to display 10 rows, we'll write df.head, we'll write 10. Now we'll press Ctrl and enter, and we can see 10 rows are being displayed. So this is how you can import and showcase the data and all. So this was about the Google Collab. We have covered major things in that, many important things in that. There must be many more things in that you will explore when you will start using it. So after understanding about Google Collab and hearing about various cloud technologies, if you want to become a cloud engineer, then check our postgraduate program in cloud computing. Our comprehensive course covers Microsoft Azure, AWS and GCP, empowering you to deploy dynamic and dependable applications seamlessly. Discover the intricacies of these leading cloud platforms and master the core skill sets needed for success. Join us to transform your career and step confidently into the world of cloud computing. Enroll now and embark on an exciting journey towards a bright future in the cloud industry. Don't miss this opportunity. So if you are interested in becoming a cloud engineer or architect, then check our Cloud Architect Masters program. Simplilearn's Cloud Architect Certification course will build your AWS, Microsoft Azure, and Google Cloud Platform expertise from the ground up. You will learn to master the architectural principles and services of the top cloud platforms, design and deploy highly scalable, fault-tolerant applications, and develop skills to transform yourself into an AWS and Azure cloud. This program also has Job Assist program. Simplilearn's Job Assist program is an Indian-specific offering in partnership with iimjobs.com to help you land your dream job. To participate in Job Assist program, you need to be graduate in engineering or equivalent, or complete our master's program successfully and earn a master's certificate upon completion. So what are you waiting for? Enroll now.
So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now it's basically an online portal through which you can access and manage resources and services. Now, resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched on February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now let's talk about Azure services. Now Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have Express Route. Now with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have Virtual Network. Now with Virtual Network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored. Let's talk about Azure services. As I told you, Azure provides services for a wide range of domains. Now let's have a look at some of these domains. There's AI and machine learning, compute, containers, database, identity, management tools, networking, security, storage, and so much more. Now let's have a look at some of the individual services within these domains. Firstly, you have Azure Virtual Machines. With Azure Virtual Machines, what you get is the opportunity to create Windows or Linux virtual machines. Now all of this is possible in a matter of seconds with a large amount of customization. Now let's have a look at some of its features. Firstly, you can choose from a wide variety of virtual machine options. Then you have a large amount of optimization available to you. For example, what size of operating system do you want? How much size do you want allocated to it? What version of the system is it? And so much more. Then it provides low cost and per minute billing. Now Azure provides you per minute billing, which means that you're only charged for how much time you use the service. And finally, you have enhanced security and protection for your virtual machines. Next, we have Service Fabric. Now with Service Fabric, you have a platform which enables you to create microservices. Now this also makes the process of application lifecycle management a whole lot easier. As a direct result, you can create applications with a faster time to market. It supports Windows, Linux, on-premises or other clouds, and it enables you to do a tremendous amount of scaling up depending on your requirement. And finally, we have functions. Now with functions, you can build applications with the help of serverless computing. Here, the users only pay for the amount of resources that they've used. You can create applications in any language that you want, and the only thing you need to worry about is the code of the application. Everything other than that, that is the hardware requirements, are taken care of by Azure. Now let's have a look at the networking services. Firstly, we have the Azure CDN, or the Content Delivery Network. With Azure CDN, what you get is the ability to deliver your content with reduced load times, fast responsiveness, and less bandwidth. Now, CDN can be integrated with several other Azure services so that the process can move at a faster rate. It can handle heavy loads and traffic spikes with ease. It also provides a robust security system. Now, with the content that's delivered, you can get advanced analytic data with which you can understand how customers are using your content. Next, we have ExpressRoute. With ExpressRoute, you can connect your on-premises network to Azure through a private network. Now, by default, this lowers latency. It increases the emphasis on reliability and speed, and it can be of great use when you have to transfer large amounts of data between networks. Now, another way this can be useful is if it's used to add compute or storage capacity to data centers. Next, we have Azure DNS. Domain Name Service, or Azure DNS, can be used to host your domains on Azure. This provides high availability and great performance. It provides fast responses to DNS queries by taking advantage of Microsoft's global network. It also provides high availability. Next, we have Virtual Network. Azure Virtual Network allows the Azure resources to communicate with each other or other on-premise networks via the internet, and all of this is kept extremely secure. Now with this, users can create their own private network for communication. It provides users with an isolated and extremely secure environment for their applications to run. Now all of the traffic stays entirely within the Azure network, and it also allows users to design their own networks. Next, we have Traffic Manager. Now with Traffic Manager, you can route incoming traffic to improve your performance and availability. Now one thing it provides is multiple failover options. So if a particular situation goes wrong, there's always an option to consider to salvage the situation. It helps reduce application runtime and enables the distribution of user traffic across multiple locations. It also helps the people who are using it to know where the customers connecting from across the world. Next, we have Load Balancer. With this, you are provided the ability to instantly scale applications at the same time providing high availability and improved network performance for users' applications. It can be integrated into virtual machines and cloud services. It provides highly reliable applications. It also allows users to secure and integrate security groups. Finally, we have Azure VPN Gateway. Now this allows users to connect their on-premise networks to Azure using a site-to-site VPN. Now this allows users to connect their virtual machine to anywhere in the world through a point-to-site VPN. And also it's very easy to manage and is highly available. Now let's talk about the storage services. First, we have Data Lake Storage. Now with this, what you get is a scalable data storage with an emphasis on cost effectiveness and scalability. Now it comes of maximum use when you integrate it with other services so that you can get analytics on how the data is being used. It is also integrated with other services like the Azure Blob Storage. Now it is also optimized for big data analysis tools like Apache Spark and Hadoop. Next up, we have Blob Storage. Now Blob Storage provides a storage capacity for data. Now depending on how often a particular data is used, it is classified into different tiers. Now all the data that is within the Blob Storage is unstructured data. Now it has a way of ensuring that the data integrity is maintained every time a particular object is being changed or the data is being accessed. And it also helps improve app performance and reduces bandwidth consumption. Next, we have queue storage. Now with this, you have a message queuing system for large workloads. This allows users to build flexible applications and separate functions. Not to mention, with this, you can be sure that your individual components will not fail. It also makes sure that your application is scalable. Queue storage provides queue monitoring, which helps ensure that the customer's demands are met. Then we have file storage. Now with file storage, you can perform file sharing with the help of the SMB protocol or the server message block protocol. Now this data is protected by SMB 3.0 and the HTTPS protocol. In this case, like we mentioned in functions, Azure takes care of all the hardware needs and the operating system deployments on its own. It also improves on-premises performance and other capabilities. Lastly, we have table storage. With table storage, you can deploy semi-structured datasets and a NoSQL key value store. Now this is used for creating applications which have a flexible data schema, and also considering how it has a very strong consistency model, it's mainly aimed for enterprises. Next, let's have a look at some web and mobile services. First, we have the Azure Search. Now with Azure Search, you get a cloud search service which is powered by artificial intelligence. With this, you can develop web applications as well as mobile applications. Now one big advantage is that you don't have to set up or manage your search indices. Azure takes care of that, and by extension, it increases your development speed. The artificial intelligence also will provide insights and structured information that you can use to improve the search and structured information. Next, we have logic apps. Now with this, you can create integration solutions which can connect applications that are important to your business. Now with this, you can visually create business processes and workflows. You can integrate SaaS or software as a service applications and enterprise applications. And more importantly, it allows you to unlock data within a firewall and securely connect to services. Next, we have web applications. Now with web apps, you can create, deploy, and scale web applications according to business requirements. Now it supports both Windows and Linux platforms, and it helps with continuous integration or deployment abilities. Another very important aspect of this is that the data can be deployed and hosted across multiple locations in the world. And finally, we have mobile apps. With mobile apps, you can create applications for iOS, Android, and Windows platforms. One advantage is that it automatically scales up and down based on your requirements. Now, in situations where you have network issues, offline data syncing ensures that your applications work anyway. And you can create cross-platform applications or native applications for iOS, Android, and Windows. Next, let's have a look at some container services. First, let's talk about ACS or Azure Container Services. It is also known as the Azure Kubernetes Services, as it's a fully managed Kubernetes container orchestration service. Now, what this means is that it eases the process of container integration and deployment. It also can be used with other resources from security like virtual networks, cryptographic keys, and so much more to ensure that your container is kept secure. Next, we have container instances. Now, this is similar to functions in a way, just that in this we're using containers without having to manage servers. Now, applications can be developed here without managing virtual machines or learning new tools. All that is Azure's problem to take care of. And it enables building applications without having to manage the infrastructure. That is, all you need to worry about is running the container. Next, let's have a look at some database services. First, we have the SQL database. Now with SQL database, what you get is a relational cloud database service. Now, this means that it helps accelerate your app development and makes it easier for you to maintain your application. Now, SQL database is also used extensively in migrating workloads to the cloud, and hence saves time and cost. It also helps improve your performance by integrating machine learning and adaptive technologies into your database. Next, we have Azure Cosmos DB. Now, this is a globally distributed multi-model database service. Now, what this means is that with this, you can create applications which support NoSQL. It provides a high-grade security system, has high availability and low latency. Now, this is usually used in situations where you have a diverse and highly unpredictable workload. Now, let's have a look at some security and identity services. Firstly, we have the Azure Active Directory. Now, if you want to know more about Azure Active Directory, I suggest you click on the top right corner and watch our video on the Azure Active Directory. This is just an introduction. So with this, you can manage user identities and you can make sure the resources are kept safe with the help of access policies. Most of these are intelligence driven. Now, one of the main features is that you can have access to your applications from any location or device. It helps increase your efficiency and helps down cutting costs when it comes to having a help desk. It can also help improve security and can respond to advanced threats in real time. Next, you have Azure Active Directory B2C. It helps provide customer identity and access management in the cloud. Now, protecting customer identity is extremely important for an organization, and that's what Azure AD B2C does. Now, it also enables the application to be scaled to great amounts, even billions of customers. Next, we have the Azure Security Center. This is basically like a command post with which you get a complete view of the security across users on your on-premises and cloud workloads. So with this, you are given a threat protection method that adapts to situations and helps reduce exposing you to threats. It also has rapid threat response and makes the process of finding and fixing vulnerabilities a whole lot easier. Next up, let's talk about monitoring and management services. So first, let's have a look at Azure Advisor. Now, Azure Advisor is basically a guide for the best practices when it comes to Azure. Now, when you follow these, it improves performance, security, cost, and increases availability. Now, it also learns from how you use the services on your configuration and usage pattern, and the adjustments that it suggests can be implemented very quickly and easily. Next, we have Network Watcher. Now, with this, you can monitor, diagnose, and understand the working of your network. Now, you can monitor your network without actually having to log in to your virtual machine. Now, you can also use something known as network security flow logs to understand the traffic pattern, how much traffic is coming towards you, how much you're giving, and so much more. It also helps diagnose VPN problems that you might have with detailed logs. And finally, you have the Azure Resource Manager. Now, with this, you can ensure that the resources that you have are managed and deployed at a consistent rate. Now, this makes it extremely easy for you to manage and visualize your resources that are used in your applications or some other requirements, and you can control who can access your resources as well as perform actions on it. Hi guys, I'm Rahul from Simplilearn, and today I'd like to welcome you all to the greatest debate of the century. Today, I'm joined by two giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirements.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under 2 categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elasticache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now, let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GBs of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GBs of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like Platform as a Service and Infrastructure as a Service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization's requirements.
In this video, we will compare and contrast AWS, Azure, and GCP based on a few related concepts around these cloud computing platforms. It will help us understand the functioning of these top cloud platforms and will also let us figure out the individuality of each one of them. But before starting with the comparison, let's have a quick introduction of AWS versus Azure versus GCP. So let's get started. Amazon Web Services, or AWS, is a cloud computing platform that manages and maintains hardware and infrastructure, reducing the expense and complexity of purchasing and running resources on-site for businesses and individuals. These resources are available for free or for a fee per usage. Microsoft Azure is a cloud computing service that offers a collection of cloud computing services for building, testing, deploying, and managing applications in the cloud, including remotely hosted and managed versions of Microsoft technology. Google Cloud Platform offers a variety of cloud computing services for building, deploying, scaling, monitoring, and operating a cloud. The services are identical to those that power Google products, such as Google Search, Gmail, YouTube, and Google Drive. Now let's move on to the comparison between AWS, Azure, and GCP. We will be comparing them based on a few major parameters like origin, service integration, availability zone, cloud tools like compute, storage, networking, market share, pricing, and at last, who uses them. Now let's move ahead and start with the first comparison, origin. In the year 2006, Amazon Web Services, or AWS, was introduced to the market. And in the year 2010, Azure launched its services, whereas on the other hand, GCP was established in the year 2008. From the start, AWS has been supportive of the open source concept, but the open source community has a tense relationship with Azure. On the other hand, GCP, similar to AWS, provides Google Cloud with managed open source services that are tightly linked. AWS offers services on a large and complex scale that can be manipulated, but Azure's support is comparatively low quality, whereas GCP's monthly support price is almost $150 for the Silver class, which is the most basic of services and is quite expensive. Now let's move on to the service integration of these cloud platforms. Service integration is a set of tools and technology that connects different applications, systems, repositories, and data and process interchange in real time. AWS makes it simple for users to combine services such as Amazon EC2, Amazon S3, Beanstalk, and others. And on the other hand, Azure allows customers to effortlessly combine Azure VMS, Azure App Service, SQL, databases, and other services. Whereas users can utilize GCP to combine services such as compute, engine, cloud storage, and cloud SQL. Now that we know briefly about all these cloud platforms, let's have a look at the availability zones of these platforms. Because AWS was the first in the cloud domain, they have had more time to build and extend their network. But Azure and GCP both have various locations around the world. But the distinction is in the amount of availability zones they have. AWS now offers 66 availability zones, with an additional 12 on the pipeline. Close to it, Azure is available in 140 countries and is available in 54 regions throughout the world. But Google Cloud Platform is now available in 20 global areas with 3 more on the way. Now let's move on to the next important factor, which is tools. Now let's move ahead and have a look at the first feature, which is compute. Elastic Compute Cloud, or EC2, is AWS's compute service, which offers a wide range of features, including a large number of instances, support for both Windows and Linux, high-performance computing, and more. Azure, on the other hand, as virtual machines, is Microsoft Azure's core cloud-based compute solution. It includes Linux, Windows Server, and other operating systems, as well as better security and Microsoft program integration. In comparison to its competitors, Google's computing services catalog is somewhat smaller. Compute Engine, that company's principal service, offers custom and predefined machine types, per-second invoicing, Linux, and Windows support, and carbon-neutral infrastructure that uses half the energy of traditional data centers. Within the compute category, Amazon's different container services are gaining prominence. It has Docker, Kubernetes, and it's also Fargate service, which automates server and cluster management when using containers, as well as other alternatives. Azure, unlike AWS, uses virtual machine scale sets of 2 container services. Azure Container Services is based on Kubernetes, and Container Service uses Docker, Hub, and Azure Container Registry for management. For enterprises interested in deploying containers, Google offers the Kubernetes engine. And it's also worth noting that Google was significantly involved in the Kubernetes project, providing an extensive knowledge in this field. Now let's move on to the next parameter of comparison, which is storage. Simple Storage Service for object storage, Elastic Block Storage for persistent block storage, and Elastic File System for file storage are among AWS's storage offerings. Block storage for REST-based object storage of unstructured data, queue storage for a large volume workload, file storage, and disk storage are among Microsoft Azure core storage services. GCP offers an increasing number of storage options. Its Unified Object Storage Service, Cloud Storage, also has a persistent disk option. Relational Database Service, or RDS, DynamoDB, NoSQL Database, Elastic In-Memory Data Store, Redshift Data Warehouse, Neptune Graph Database, and Database Migration Service are all SQL-compatible databases offered by Amazon. The database choices in Azure are specifically wide. SQL Database, MySQL Database, and PostgreSQL Database are the 3 SQL-based choices. Now, when it comes to databases, GCP offers the SQL-based Cloud SQL and Cloud Spanner, a relational database built for mission-critical workloads. Now, the next parameter is networking. AWS uses Amazon Virtual Private Cloud, or VPC. On the other hand, Azure uses Azure Virtual Network, or VNet. And GCP uses Cloud Virtual Network. Now let's move on to another factor, which is market share and pricing. All these cloud services are based on comparative pricing strategies, which means you need to pay on the basis of its usage. According to Canalys, the worldwide cloud market rose 35% to $41.8 billion in the first quarter of 2021. AWS accounts for 32% of the market, with Azure accounting for 19% and Google accounting for 7%. On one hand, Amazon charges on a yearly basis, and on the other hand, Microsoft Azure and Google services charge on a minute basis. And also, all of them provide you a standard price for you to access these services. AWS charges roughly $69 per month for a very basic instance with 2 virtual CPUs and 8 gigabytes of RAM. And AWS largest instance with 3.84 TB of RAM and 128 vCPUs will set you back roughly $3.97 per hour. But in Azure, the same type of instance, one with 2 vCPUs and 8 gigabytes of RAM, cost roughly $70 US per month. And Azure's largest instance has 3.89 TB of RAM and 128 virtual CPUs, and it costs about $6.79 per hour. Compared to AWS, GCP will supply you with the most basic instance, which includes 2 virtual CPUs and 8 gigabytes of RAM for 25% less. And as a result, it will set you back roughly $52 every month. And the largest instance that includes is 3.75 TB of RAM and 160 vCPUs, and it will cost you about $5.32 per hour. Amazon, other than this, also provides spot instances, reserved instances, and dedicated host where you can look for multiple offers and discounts. But for Azure, it provides special prices to developers based on situations, or even Azure Hybrid Benefit, which benefits your organization up to 40% if it uses Microsoft software in their data centers. Whereas Google offers quite assorted pricing to its customer compared to the other two. It gives you sustained use discounts, which activate if you use the same instance for a month. The printable instance, which is very similar to Amazon's spot instances, but one thing is common in all 3 cloud services, which is that they all offer long-term discounts. Now, let's have a look at the last comparison, which is the companies that are using them. Because AWS is the oldest player in the cloud business, it has the largest user base and community support. As a result, AWS has the largest number of high-profile and well-known clients, including Netflix, Airbnb, Unilever, BMW, Samsung, Misinga, and others. With time, Azure is getting a large number of high-profile customers. Azure currently boasts around 80% of Fortune 500 firms as customers. Johnson Controls, Polycom, Fujifilm, HP, Honeywell, Apple, and others are among its key clients. Google Cloud, on the other hand, uses the same infrastructure as Google Search and YouTube, and as a result, many high-end enterprises trust Google Cloud. HSBC, PayPal, 20th Century Fox, Bloomberg, Domino's, and other are among Google Cloud's many clients.
Remember to hit that subscribe button and tap the notification bell so you are always in the know. And before we begin, if you are someone who is interested in building a career in cloud computing by graduating from the best universities, or a professional who elicits to switch careers with cloud computing by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in cloud computing with certificates aligned with AWS Partner Network and Silver Microsoft Partner. The link is mentioned in the description box below that will navigate you to the course page, and you can have a complete overview of the program being offered. Now let's dive right in. So first we'll see the career with Cloud Associate Cloud Engineer. Leave the server racks behind and venture into the dynamic world of cloud computing. The perfect moment has arrived, and now let's talk about what this certification means for you. Your Associate Cloud Engineer certification is like a beacon, signaling to prospective employers your prowess in Google Cloud. As an Associate Cloud Engineer, you will be adept at deploying and securing applications and infrastructure. You will maintain enterprise solutions to meet performance standards and keep a watchful eye on the operations of multiple cloud projects. But that's not all. Associate Cloud Engineers also prove their mastery in using the Google Cloud Console and command line interface. You will effortlessly manage and scale cloud solutions, leveraging Google managed or self-managed services on Google Cloud. And many of our peers once dwelled in the on-premises realm, meticulously setting up servers. Now they are prepared to level up their skills for the cloud era. The Associate Cloud Engineer certification is your stepping stone to a flourishing IT career. So picture yourself as a cloud developer, architect, security engineer, systems engineer, or network engineer. The possibilities are endless. So let's get started with the benefits of doing GCP ACE. So the first benefit you can gain by acing this certification is you will have the membership to Google Credential Holder Portal. So I will show you. So this is the Google Cloud Certified Directory. Here you can find all the people who have cleared this certification, and you can just click on their LinkedIn profile and see what skills they possess. And you have other filters also, that is you can search by the credentials, locations, or skills. So this is the first benefit of doing GCP ACE. Now moving back, the second benefit is exposure to all GCP services while preparation will boost your confidence. And then this will set a good foundation for professional architect exam and Google certification and badge to be used in your profile for visibility. That will uphold your profile and will gain you many opportunities. And now we'll see steps what you can follow to ace the GCP ACE certification exam. So before we dive in, it's essential to grasp the exam structure. The Google Associate Cloud Engineer Certification exam consists of 50 multiple choice questions and you have a total of 2 hours to complete it. A passing score requires at least 70% correctness. This exam evaluates your knowledge of Google Cloud Platform Services, basic networking concepts and cloud computing fundamentals. And the recommended experience for this certification is 6+ months. And the prerequisites are none for this certification exam. And the link to register for this exam, I will mention that link in the description box below and I will show you the link also. So this is the link. Here you have to go and make your profile if you don't have an account, and after that you can log in. So this is here where you will register for the exam. And moving back, now we'll see the step 2, that is getting familiar with GCP. So to succeed, you need to become best friends with Google Cloud Platform. Luckily, Google offers a free tier that allows you to explore GCP's product and services without cost. And don't forget about the comprehensive GCP documentation. It's your treasure trove of insights into various services and functionalities. So you can just go to the documentation and read it. And the third is enroll in a course or training program. So education is the key here. Enroll in a course or training program tailored to the Google Associate Cloud Engineer exam. The Simplilearn Caltech Cloud Computing Bootcamp course lets you master key architectural principles and develop the skills needed to become a cloud expert and provides in-depth coverage of exam topics. Or if you prefer hands-on experience, the Associate Cloud Engineer Exam Prep Quest from Quick Labs is a great choice. And I will mention the link for the bootcamp in the description box. You can go there and you can enroll in a course or training program to ace the preparation. And now the step 4. Take practice test. Sharpen your skills with practice test. Google Cloud offers official practice test for purchase which give you a real feel for the exam environment. Cloud Guru and Wiz Labs also provide valuable practice exams. And if you are budget conscious, Exam Labs offer free practice test. And now moving on to the step 5. Review exam objectives and resources. So stay focused by reviewing the exam objectives outlined by Google Cloud. These guides serve as your roadmap to success. Dive deep into Google Cloud's documentation and white papers for additional study materials. Don't forget to engage with the Google Cloud community on Reddit for valuable insights and tips. And now talking about the syllabus, I will move to the website directly only. So this is the syllabus for Google Cloud Architect. So here you will learn and you should know the setting up a cloud solution environment for setting up organization resources. That is, then you should have a knowledge on planning and configuring a cloud solution, deploying and implementing a cloud solution, and ensuring successful operation of a cloud solution. So these all are the things that are covered in the syllabus. So you should have a hands on that. As I told you about the bootcamp, so all these syllabus topics are covered in that bootcamp or the postgraduate program that I mentioned in the starting. So if you want to ace the program, you can just enroll in the course or training program. And now moving back, now we'll just have a look at the tips to ace this exam. So the first tip is book the exam in advance before starting preparation so you don't miss out. And the second tip is practice, practice and practice. That will help you clear that certification. And the third tip is start the exam with a relaxed mind and take pauses after 5 questions each time. That really helps. And then we have the fourth tip, that is understand intention of question. Look for keywords in questions and answers. And the tip 5, while choosing options, focus on available option. Do not worry about perfect answer. And there you have it, Tech Explorers, your gateway to a cloud-powered future awaits. The Cloud Engineer Learning Path, crowned by the revamped Preparing for the Associate Cloud Engineer Certification course, is your compass to steer your career toward new horizons. Now let's take a minute to hear from our learners who have experienced massive success in their careers.
Cloud computing has completely changed our world. It allows us to store and access our data from anywhere, making our life more convenient. Plus, we can now work with people from all over the world without a hitch. All thanks to cloud computing. So cloud projects are a big part of this change. They help us learn and try out new things with cloud technology, which is really important. It's like a playground for learning and solving real-world problems. So whether you're making an intelligent gadget, creating a website, or even predicting the weather, cloud computing does play an important role. So here we are with another video on top 10 cloud computing projects in 2024. Whether you are a beginner, an intermediate level cloud enthusiast, or an advanced level cloud expert, we have got you covered here. So hey everyone, and you are already watching Simplilearn. Before starting with the top 10 cloud computing projects for 2024, subscribe to our channel because we bring the best videos for you daily. Also hit the bell icon to never miss any updates from Simplilearn. Also, do check out the Cloud Architect Masters program by Simplilearn. This program will help you build your AWS, Microsoft Azure, and Google Cloud Platform expertise from the ground up. You'll learn to master the architectural principles and services of the top cloud platforms, design and deploy highly scalable, fault-tolerant applications, and develop skills to transform yourself into an AWS and Azure cloud expert. This program will give you an in-depth understanding of cloud services such as AWS CloudFormation, Azure Resource Manager, EC2, S3, Route 53, VPC, Azure App Services, GCP, and much more. You will acquire the knowledge and skills for passing Cloud Architect certifications such as AWS Architect and Azure Architect. Candidates with 1+ year of work experience are preferred to enroll in this program by Simplilearn. So check out the link mentioned in the description box below for more details.
Moving on to the top 10 cloud computing projects, we have divided this video into 3 parts. The first part is for beginners. Moving on to the first project for beginners, we have a cloud-based file storage. In this project, you will create a simple cloud-based file storage system similar to a Dropbox or a Google Drive. Users can upload, download, and manage files stored in the cloud. The part to create this project will start by choosing a cloud storage service. Select a cloud storage service provider like AWS S3, Google Cloud Storage, or Azure Blob Storage. The next step is creating an account. Sign up for an account with the chosen cloud provider if you don't already have one. The next step is to set up a bucket or a container. Create a storage bucket or container to store your files. The next step is to develop a web interface. Create a web-based interface for users to interact with your storage system. You can use HTML, CSS, and JavaScript for this. The next step is to implement file upload and download. Add functionality for users to upload and download files to or from their storage bucket using the cloud provider's SDK or API. The next step is user authentication. Implement user authentication to secure access to files. You can use services like Firebase authentication or build one of your own. The next step is testing and deployment. Test your file storage system locally, and once satisfied, deploy it to the cloud. Make it publicly accessible if needed. The key learning points of this project is you will learn the basics of cloud storage services, file uploading and downloading, and user authentication. Moving on to project number 2, we have a website hosting service. This project involves setting up an essential website on a cloud platform like AWS, Azure, or Google Cloud. You will deploy a static or dynamic website and make it accessible to users worldwide. Let's move on to the path to create this project. The first step is to select a cloud hosting service. Choose a cloud hosting platform like Amazon Web Services, Azure, or Google Cloud. The next step is to design your website. Create the content and design for your website. You can use HTML, CSS, and JavaScript for static websites or web frameworks for dynamic ones. Then register a domain name. Purchase a domain name from a domain registrar, for example GoDaddy, Namecheap, etc. The next step is to configure DNS. Configure the DNS setting to point to your cloud hosting server's IP address. The next step is to set up a virtual server. Create a virtual server instance on your chosen cloud platform, for example AWS EC2, Azure VM, and Google Compute Engine. The next step is to install web server software. Install and configure web server software like Apache on your virtual server. And the last step is to upload website files. Upload your website files to the server, and then you are done with the project. The key learning points of this project: you will learn how to configure a web server. You will deploy web applications and manage domain names, and finally you will ensure high availability. The next project we have for beginners is a cloud-based calculator. Create a simple web-based calculator application and deploy it on a cloud platform like Heroku. Users can perform basic calculations using this calculator. Let's talk about the path to create this project. You will start by selecting a cloud platform. Choose a cloud platform like Heroku, AWS or Azure for deployment. Then develop the calculator. Create a simple web-based calculator. You can use HTML, CSS and JavaScript for this. Then set up a development environment. Install necessary development tools and libraries on your local machine. Then move ahead with version control. Use version control systems like Git to manage your project. Then create a cloud account. Sign up for an account with your chosen cloud platform. Then comes the deployment part. Deploy your calculator application to the cloud platform of your choice. For Heroku, this might involve pushing your code to a Git repository. And then comes the testing part. Ensure that the calculator functions correctly on the cloud server. Let's talk about the key learning points of this project. You will gain experience in setting up cloud server environments, deploying web applications, and understanding server-client interactions. Moving on to intermediate level projects. These projects are for people with decent knowledge of cloud computing basics. The first project we have in this category is an IoT data analytics project. Build a system that collects data from IoT devices, sensors, smart devices, etc. and stores it in cloud databases, for example, AWS DynamoDB or Azure Cosmos database. Implement analytics to gain insights from the collected data. Let's talk about the path to create this project. The first step is IoT device setup. Set up IoT devices or sensors to collect data. Then choose a cloud database. Select a cloud database service, for example, AWS Dynamo database, Azure Cosmos database for data storage. Then comes the data ingestion part. Write code to send data from IoT devices to the cloud database. Then comes data analytics. Implement data analytics tools or scripts to analyze the collected data. Then comes data visualization. Create visualizations to present insights from the data using tools like AWS QuickSight or data visualizations libraries. And then the last part is monitoring and scaling. Implement monitoring and scaling mechanisms to handle increased data volumes. So let's talk about the key learning points of this project. You will explore IoT data ingestion, cloud database management, data analytics, and of course data visualization. Moving on to the next project, we have a video streaming service. So you will create a video streaming service where users can upload and stream videos from the cloud. Implement features like video encoding, content delivery, and user authentication. Let's talk about the path to create this project. You will start by selecting cloud services. Choose cloud services for video storage, for example AWS S3. For encoding you can choose AWS Elastic Transcoder, and for content delivery you can choose AWS CloudFront. The next step is to design the application. Plan the architecture of your video streaming platform, including user interfaces for uploading and streaming. The next step is user authentication. Implement user authentication using services like AWS Cognito. Then comes the video uploading part. Allow users to upload videos to the cloud storage. And then comes the video encoding. Implement video encoding to create different quality versions of uploaded videos. Then comes the content delivery. Use a content delivery network or CDN to distribute videos efficiently to the users. And the last step is testing and scalability. Test video streaming and ensure it scales to handle concurrent users and varying network conditions. Let's talk about the key learning points for this project. You will learn about video processing, content delivery networks, and secure user access control. Moving on to the next project, we have cloud-based e-commerce website. Build an e-commerce platform hosted on cloud. Develop features like product listing, shopping carts, and secure payment processing. Let's talk about the path to create this project. You will start by selecting cloud platform. Choose a cloud platform, for example AWS or Azure, to host your e-commerce application. Then comes the e-commerce framework. Choose an e-commerce framework, for example WooCommerce or Shopify, or build a custom solution. Then comes the product listings part. Add product listings and descriptions with images. Then comes the shopping cart. Implement a shopping cart functionality for users to add products. Then comes the secure payment processing. Set up secure payment processing using payment gateways like Stripe or PayPal. Then comes the user authentication part. implement user authentication for customer accounts, and finally the testing and security. Thoroughly test your e-commerce website, ensuring it's secure and capable of handling transactions. What are the key points of this project? You will gain experience in building scalable web applications, handling online transactions securely, and managing customer data. Talking about advanced level cloud computing projects. For advanced level cloud computing projects, you should master cloud infrastructure and cloud services. The first advanced level project we have for today is machine learning with cloud. Develop a machine learning model and deploy it on a cloud server for scalable processing. This project involves working with large data sets and real-time data analysis. The first step is machine learning model. Develop a machine learning model using libraries like TensorFlow or scikit-learn. Then comes the data preparation part. Prepare and clean the data for training and testing. Then choose a cloud machine learning service. Select a cloud machine learning service, for example, AWS SageMaker, Google AI Platform, and etc. Then comes the model deployment part. Deploy your machine learning model on the cloud platform. And finally, the scalability. Ensure the model can handle real-time predictions and scale as needed. Let's talk about the key learning points of this project. You will delve into machine learning, cloud-based data processing, and model deployment. The next project we have in this list is the cloud-based virtual desktop. Create a system that allows users to access virtualized desktop environments hosted on the cloud. This project focuses on remote desktop solutions. Talking about the path to create this project, you should start by selecting cloud service. Choose a cloud service for virtual desktop. For example, Amazon Workspace, Windows Virtual Desktop, or Azure. Then comes the configuration part. Configure virtual desktop instances with desired specifications. User management. Create and manage user accounts for accessing virtual desktops. Security. Implement security measures for data protection during remote desktop access. Then comes the access control part. Set up access control policies to restrict user permissions. And lastly, testing. Test the remote desktop access from different devices and locations. Talking about the key learning points of this project, you'll learn about virtualization, remote desktop technologies, and user management in a cloud-based context. Moving on to the third advanced level cloud project, we have a cloud gaming service. Build a cloud-based gaming service similar to Google Stadia. This project involves GPU virtualization, low latency streaming, and multiplayer game server management. Talking about the path to create this project, you should start by selecting cloud infrastructure. Choose a cloud infrastructure. You can either choose AWS or Azure for hosting game servers. Then comes the game server setup. Set up game servers for hosting games. Then comes the low latency streaming. Implement low latency streaming technologies for gameplay. Then comes the multiplayer support. Add multiplayer support for users to play together. Then comes the user management. Create user accounts and manage players' profiles. And finally comes load balancing. Implement load balancing to handle increased player loads. Talking about the key learning points of this project, you will explore cloud-based gaming infrastructure, server management, and real-time multiplayer networking. Moving on to the last cloud computing project, we have a healthcare data management system. Develop a cloud-based system for storing and managing healthcare-related data such as patient records. Ensure compliance with healthcare industry standards, for example, HIPAA. Talking about the path to create this project, you should start by ensuring compliance with healthcare industry standards. HIPAA compliance. Understand and adhere to HIPAA compliance regulations. Cloud platform selection. Choose a HIPAA compliant cloud platform, for example, AWS Healthcare APIs and Azure for healthcare. Then comes the data storage part. Create a secure cloud-based data storage system for healthcare records. Then comes the access control. Implement strict access controls and encryption for data security. Then comes the audit trials. Maintain audit trials for data access and modifications. And then at last comes the user training. Ensure staff are trained on HIPAA compliance and data handling protocols. Talking about the key learning points of this project, you will gain expertise in cloud security, data privacy, and compliance while addressing real-world healthcare data challenges. These projects provide a progressive learning path allowing individuals to start with basic cloud concepts and gradually advance to more complex and impactful cloud computing applications. Each project offers valuable experience and skills that can be applied to real-life scenarios and career development in the cloud computing field.
So if you are interested in becoming a cloud engineer or architect, then check our Cloud Architect Masters program. Simplilearn's Cloud Architect certification course will build your AWS, Microsoft Azure, and Google Cloud Platform expertise from the ground up. You will learn to master the architectural principles and services of the top cloud platforms, design and deploy highly scalable, fault-tolerant applications, and develop skills to transform yourself into an AWS and Azure cloud. This program also has Job Assist program. Simplilearn's Job Assist program is an Indian-specific offering in partnership with iimjobs.com to help you land your dream job. To participate in Job Assist program, you need to be graduate in engineering or equivalent, or complete our master's program successfully and earn a master's certificate upon completion. So what are you waiting for? Enroll now.
Hey everyone, welcome to Simplilearn's YouTube channel. Today we will be discussing the cloud computing interview questions. But before that, let me share a few facts with you. According to O'Reilly, more than 90% of the organizations are expected to increase their cloud infrastructure. In 2021, the upshot is that the majority of cloud users plan to scale their business in the cloud rather than reducing their cloud usage share. Suppose you are very much interested in cloud industry, then you have come to the right place. Welcome to this video on cloud computing interview questions. In this video, we will learn everything about AWS and Azure in detail. Our interview questions are divided into 3 segments: beginner level, intermediate level, and advanced level. By the end of this video, I can assure you that all your AWS and Azure related queries would have been answered. For this training with me, I have our experienced AWS and Azure expert Sam, who will take you through the various topics of Azure. So let's get started with an exciting video on cloud computing interview questions. Before we begin, please make sure to get subscribed to our YouTube channel and hit that bell icon to never miss an update from Simplilearn.
Hi there, I'm Samuel and I'm here to walk you through some of the AWS interview questions which we find are important, and our hope is that you would use this material in your interview preparation and be able to crack that cloud interview and step into your dream cloud job. By the way, I'm a cloud technical architect, trainer, and an interview panelist for cloud, network, and DevOps. So as you progress in watching, you're going to see that these questions are practical scenario-based questions that tests the depth of the knowledge of a person in a particular AWS product or in a particular AWS architecture. So why wait? Let's move on. Alright, so in an interview, you would find yourself with a question that might ask you, define and explain the 3 basic types of cloud services and the AWS products that are built based on them. See, here, it's a very straightforward question. Just explain 3 basic types of cloud service. And when we talk about basic type of cloud service, it's compute, obviously, that's a very basic service. Storage, obviously, because you need to store your data somewhere. And networking, that actually connects a couple of other services to your application. These basic will not include monitoring. These basic will not include analytics because they are considered as optional. They are considered as advanced services. You could choose a non-cloud service or a product for monitoring and for analytics. So they're not considered as basic. So when we talk about basics, they are compute, storage, and networking. And the second part of the question says, explain some of the AWS products that are built based on them. Of course, compute, EC2 is a major one. That's the major share of the compute resource. And then we have platform as a service, which is Elastic Beanstalk. And then function as a service, which is Lambda. Auto scaling and light sail are also part of compute services. So the compute domain, it really helps us to run any application, and the compute service helps us in managing the scaling and deployment of an application. Again, Lambda is a compute service, so the compute service also helps in running event initiated stateless applications. The next one was storage. A lot of emphasis is on storage these days because if there's one thing that grows in a network on a daily basis, that's storage. Every new day we have new data to store, process, manage. So storage is again a basic and an important cloud service. And the products that are built based on the storage services are S3, object storage, Glacier for archiving, EBS, Elastic Block Storage, as a drive attachment for the EC2 instances, and EFS, file share for the EC2 instances. So the storage domain helps in the following aspects. It holds all the information that the application uses, so it's the application data. And we can also archive old data using storage, which would be Glacier, and any object files and any requirement for block storage can be met through Elastic Block Store and S3, which is again an object storage. Talking about networks, it's just not important to answer the question with the name of the services and the name of the product. It'll also be good if you could go in depth and explain how they can be used, right? So that actually proves you to be a person knowledgeable enough in that particular service or product. So talking about networking domain, VPC, networking, can't imagine networking without VPC in a cloud environment, especially in AWS cloud environment. And then we have Route 53 for domain resolution or for DNS. And then we have CloudFront, which is an edge caching service that helps customers to read their application with low latency. So networking domain helps with some of the following use cases. It controls and manages the connectivity of the AWS services within our account. And we can also pick an IP address range. If you're a network engineer, or if you are somebody who works in networks or are planning to work in network, you will soon realize the importance of choosing your own IP address for easy remembering. So having an option to have your own IP address in the cloud, own range of IP address in the cloud, it really helps, really helps in cloud networking. The other question that get asked would be the difference between the availability zone and the region. Actually, the question generally gets asked so to test how well you can actually differentiate and also correlate the availability zone and the region relationship, right? So a region is a separate geographic area like the US West 1, which represents North California, or the AP South, which represents Mumbai. So regions are a separate geographic area. On the contrary, availability zone resides inside the region. You shouldn't stop there, you should go further and explain about availability zones. And availability zones are isolated from each other, and some of the services will replicate themselves within the availability zone. So availability zone does replication within them, but regions, they don't generally do replication between them. The other question you could be asked is, what is autoscaling? What do we achieve by autoscaling? So in short, autoscaling, it helps us to automatically provision and launch new instances whenever there is an demand. It not only helps us meeting the increasing demand, it also helps in reducing the resource usage when there is low demand. So autoscaling also allows us to decrease the resources or resource capacity as per the need of that particular hour. Now, this helps business in not worrying about putting more effort in managing or continuously monitoring the server to see if they have the needed resource or not, because autoscaling is going to handle it for us. So business does not need to worry about it. And autoscaling is one big reason why people would want to go and pick a cloud service, especially an AWS service. The ability to increase and shrink based on the need of that hour. That's how powerful is autoscaling. The other question you could get asked is, what's geo-targeting in CloudFront? Now we know that CloudFront is caching, and it caches content globally in the Amazon caching service global wide. The whole point is to provide users worldwide access to the data from a very nearest server possible. That's the whole point in using or going for CloudFront. Then what do you mean by geo-targeting? Geo-targeting is showing customer and specific content. Based on language, we can customize the content. Based on what's popular in that place, we can actually customize the content. The URL is the same, but we could actually change the content a little bit not the whole content, otherwise it would be dynamic, but we can change the content a little bit, a specific file or a picture or a particular link in a website, and show customized content to users who will be in different parts of the globe. So how does it happen? CloudFront will detect the country where the viewers are located, and it will forward the country code to the origin server. And once the origin server gets the specialized or a specific country code, it will change the content and it will send to the caching server, and it gets cached there forever. And the user gets to view a content which is personalized for them for the country they are in. The other question you could get asked is the steps involved in using CloudFormation or creating a CloudFormation or backing up an environment with a CloudFormation template. We all know that if there is a template, we can simply run it and it provisions the environment, but there is a lot more going into it. So the first step in moving towards infrastructure as a code is to create the CloudFormation template, which as of now supports JSON and YAML file format. So first create the CloudFormation template and then save the code in an S3 bucket. S3 bucket serves as the repository for our code, and then from the CloudFormation call the file in the S3 bucket and create a stack. And now CloudFormation uses the file, reads the file, understands services that are being called, understands the order, understands how they are connected with each other. CloudFormation is actually an intelligent service. It understands the relation. Based on the code, it would understand the relationship between the different services, and it would set an order for itself and then would provision the services one after the other. Let's say a service has a dependency, and the dependent service, the other service which this service, let's say service A and B, service B is dependent on service A, let's say. CloudFormation is an intelligent service. It would provision the resource A first and then would provision resource B. What happens if we inverse the order? If we inverse the order, resource B first gets provision, and because it does not have dependency, chances that the CloudFormation's default behavior is that if something is not provisioned properly, if something is not healthy, it would roll back. Chances that the environment provisioning will roll back. So to avoid that, CloudFormation first provisions all the services that has or that's dependent on, that's depended by another service. So it provisions those services first and then provisions the services that has dependencies. And if you're being hired for a DevOps or if the interviewer wanted to test your skill on systems side, this definitely would be a question in his list. How do you upgrade or downgrade a system with near zero downtime? Now everybody's moving towards zero downtime or near zero downtime. All of them want their application to be highly available. So the question would be, how do you actually upgrade or downgrade a system with near zero downtime? Now we all know that I can upgrade an EC2 instance to a better EC2 instance by changing the instance type, stopping and starting. But stopping and starting is going to cause a downtime, right? So you should be answering, or you shouldn't be thinking in those terms, because that's a wrong answer. Specifically, the interviewer wants to know, how do you upgrade a system with zero downtime? So upgrading system with zero downtime, it includes launching another system parallelly with the bigger EC2 instance type with the bigger capacity, and install all that's needed. If you're going to use an AMI of the old machine, well and good. You don't have to go through installing all the updates and installing all the application. From the AMI, once you've launched it in a bigger instance, locally test the application to see if it is working. Don't put it on production yet. Test the application to see if it is working. And if the application works, we can actually swap. If your server is behind Route 53, let's say, all that you could do is go to Route 53, update the information with the new IP address of the new server, and that's going to send traffic to the new server now. So the cutover is handled. Or if you're using static IP, you can actually remove the static IP from the old machine and assign it to the new machine. That's one way of doing it. Or if you are using elastic NIC card, you can actually remove the NIC card from the old machine and attach the NIC card to the new machine. So that way we would get near zero downtime. If you're hired for an architect level, you should be worrying about cost as well, along with the technology. And this question would test how well you manage cost. So what are the tools and techniques we can use in AWS to identify and know that we are paying the correct amount for the resources that we are using? Or how do you get a visibility of your AWS resources running? One way is to check the billing. There's a place where you can check the top services that were utilized. It could be free and it could be paid service as well. Top services that can be utilized. It's actually in the dashboard of the cost management console. So that table here shows the top 5 most used services. So looking at it, you can get it. All right, so I'm using a lot of storage. I'm using a lot of EC2. Why is storage high? You can go ahead and try to justify that, and you will find if you are storing things that shouldn't be storing, and then clean it up. Why is compute capacity so high? Why is data transfer so high? So if you start thinking in those levels, you'll be able to dig in and clean up unnecessary and be able to save your bill. And there are cost explorer services available which will help you to view your usage pattern or view your spending for the past 13 months or so, and it will also forecast for the next 3 months. Now, how much will you be using if your pattern is like this? So that will actually help and will give you a visibility on how much you have spent, how much you will be spending if the trend continues. Budgets are another excellent way to control cost. You can actually set a budget. All right, this is how much I am willing to spend for this application, for this team, or for this month, for this particular resource. So you can actually put a budget mark, and anytime it exceeds, anytime it's nearing, you would get an alarm saying that, well, we're about to reach the allocated budget amount, stuff like that. That way you can go back and know, and you know that how much the bill is going to be for that month, or you can take steps to control bill amount for that particular month. So AWS budget is another very good tool that you could use. Cost allocation tags helps in identifying which team or which resource has spent more in that particular month. Instead of looking at the bill as one list with no specifications into it and looking at it as an expenditure list, you can actually break it down and tag the expenditure to the teams with cost allocation tags. The dev team has spent so much. The production team has spent so much. The training team has spent more than the dev and the production team. Why is that? Now, you'll be able to think in those levels only if you have cost allocation tags. Now, cost allocation tags are nothing but the tags that you would put when you create a resource. So for production services, you would put as a production tag, you would create a production tag and you would associate that resources to it. And at a later point, when you actually pull up your bill, that's going to show a detailed list of this is the owner, this is the group, and this is how much they have used in the last month. And you can move forward with your investigation and encourage or stop users using more services with the cost allocation tags. The other famous question is, are there any other tools or is there any other way of accessing AWS resource other than the console? Console is GUI, right? So in other words, other than GUI, how would you use the AWS resource and how familiar are you with those tools and technologies? The other tools that are available that we can leverage and access the AWS resource are, of course, PuTTY. You can configure PuTTY to access the AWS resources, like log into an EC2 instance. An EC2 instance does not always have to be logged in through the console. You could use PuTTY to log into an EC2 instance, and like the jump box, like the proxy machine, and like the gateway machine, and from there you can actually access the rest of the resources. So this is an alternative to the console. And of course, we have the AWS CLI in any of the Linux machines or Windows machines. We can install, so that's point 2, 3 and 4. We can install AWS CLI for Linux, Windows, also for Mac. So we can install them, and from there, from your local machine, we can access, run AWS commands and access, provision, monitor the AWS resources. The other ones are, we can access the AWS resource programmatically using AWS SDK and Eclipse. So these are a bunch of options we have to use the AWS resource other than the console. If you're interviewed in a company or by a company that focuses more on security and want to use AWS native services for their security, then you would come across this question. What services can be used to create a centralized logging solution? The basic services we could use are CloudWatch logs, store them in S3, and then use Elasticsearch to visualize them, and use Kinesis to move the data from S3 to Elasticsearch. Right? So log management, it actually helps organizations to track the relationship between operational and security changes and the events that got triggered based on those logs. Instead of logging into an instance or instead of logging into the environment and checking the resources physically, I can come to a fair conclusion by just looking at the logs. Every time there's a change, the system will scream and it gets tracked in the CloudWatch, and then CloudWatch pushes it to S3. Kinesis pushes the data from S3 to Elasticsearch, and I can do a time-based filter, and I would get a fair understanding of what was going on in the environment for the past 1 hour or whatever the time window that I wanted to look at. So it helps in getting a good understanding of the infrastructure as a whole. All the logs are getting saved in one place, so all the infrastructure logs are getting saved in one place, so it's easy for me to look at it in an infrastructure perspective. So we know the services that can be used, and here are some of the services and how they actually connect to each other. It could be logs that belongs to one account, it could be logs that belongs to multiple accounts. It doesn't matter. Those three services are going to work fairly good, and they're going to inject or they're going to suck logs from the other accounts, put it in one place and help us to monitor. So as you see, you have CloudWatch here that actually tracks the metrics. You can also use CloudTrail if you want to log API calls as well, push them in an S3 bucket. So there are different types of log. Flow logs are getting captured in an instance. Application logs are getting captured from the same VPC, from a different VPC, from the same account, from a different account. And all of them are analyzed using Elasticsearch using the Kibana client. So step 1 is to deploy the ECS cluster. Step 2 is to restrict access to the ECS cluster because it's valid data. You don't want anybody to put their hands and access their data. So restrict access to the ECS dashboard. And we could use Lambda also to push the data from CloudWatch to the Elasticsearch domain. And then Kibana is actually the graphical tool that helps us to visualize the logs instead of looking at log as just statements or in a bunch of characters, a bunch of files. Kibana helps us to analyze the logs in a graphical or a chart or a bar diagram format. Again, in an interview, the interviewer is more concerned about testing your knowledge on AWS security products, especially on the logging, monitoring, event management or incident management. Then you could have a question like this: what are the native AWS security logging capabilities? Now, most of the services have their own logging in them, like S3. S3 has its own login, and CloudFront has its own logging. DS has its own logging. VPC has its own logging. In addition, there are account level logins like CloudTrail and AWS config services. So there are a variety of logging options available in the AWS like CloudTrail, config, CloudFront, Redshift logging, RDS logging, VPC flow logs, S3 object logging, S3 access logging, stuff like that. So we're going to look at two servers in specific. CloudTrail. Now this CloudTrail, the very first product in that picture we just saw, the CloudTrail provides an very high level history of the API calls for all the accounts. And with that, we can actually perform a very good security analysis of our account. And these logs are actually delivered to, you can configure it, they can be delivered to S3 for long time archivals. And based on a particular event, it can also send an email notification to us saying, hey, just got this error, thought I'll let you know, stuff like that. The other one is config service. Now, config service helps us to understand the configuration changes that happened in our environment, and we can also set up notifications based on the configuration changes. So it records the cumulative changes that are made in a short period of time. So if you want to go through the lifetime of a particular resource, what are the things that happen? What are the things it went through? They can be looked at using AWS config. All right. The other question you could get asked is if your role includes taking care of cloud security as well. Then the other question you could get asked is the native services that Amazon provides to mitigate DDoS, which is denial of service. Now, not all companies would go with Amazon native services, but there are some companies which want to stick with Amazon native services just to save them from the headache of managing the other softwares or bringing in another tool, a third-party tool, into managing DDoS. They simply want to stick with Amazon proprietary Amazon native services, and a lot of companies are using Amazon service to prevent DDoS, denial of service. Now, denial of service is, if you already know what denial of service is, well and good. If you do not know, then let's know it now. Denial of service is a user trying to or maliciously making attempt to access a website or an application. The user would actually create multiple sessions and he would occupy all the sessions, and he would not let legitimate users access the service. So he's in turn denying the service for the user. A quick picture review of what denial of service is. Now look at it. These users, instead of making one connection, they are making multiple connections, and there are cheap software programs available that would actually trigger connections from different computers in the internet with different MAC addresses, so everything kind of looks legitimate for the server, and it would accept those connections and it would keep the sessions open. The actual users won't be able to use them, so that's denying the service for the actual users, denial of service. All right, and distributed denial of service is generating attacks from multiple places, from a distributed environment. So that's distributed denial of service. So the tools, the native tools that helps us to prevent the denial of service attacks in AWS is Cloud Shield and Web Access Firewall, AWS WAF. Now they are the major ones. They are designed to mitigate a denial of service. If your website is often bothered by denial of service, then we should be using AWS Shield or AWS WAF. And there are a couple of other tools that also does. When I say that also does, denial of service is not their primary job, but you could use them for denial of service. Route 53's purpose is to provide DNS. CloudFront is to provide caching. Elastic Load Balancer, ELB's work is to provide load balancing. VPC is to create an secure virtual private environment. But they also support mitigating denial of service, but not to the extent you would get in AWS Shield and AWS WAF. So AWS Shield and WAF are the primary ones, but the rest can also be used to mitigate distributed denial of service. The other tricky question is this actually will test your familiarity with the region and the services available in the region. So when you're trying to provision a service in a particular region, you're not seeing the service in that region. How do we go about fixing it, or how do we go about using the service in the cloud? It's a tricky question. And if you have not gone through such situation, you can totally blow it away. You really need to have a good understanding on regions, the services available in those regions, and what if a particular service is not available, how to go about doing it. The answer is not all services are available in all regions. Anytime Amazon announces a new service, they don't immediately publish them on all regions. They start small, and as in when the traffic increases, as in when it becomes more likable to the customers, they actually move the service to different regions. So as you see in this picture, within America, North Virginia has more services compared to Ohio or compared to North California. So within North America itself, North Virginia is the preferred one. So similarly, there are preferred regions within Europe, Middle East, and Africa, and preferred regions within Asia Pacific. So anytime we don't see a service in a particular region, chances that the service is not available in that region yet, we got to check the documentation and find the nearest region that offers that service and start using the service from that region. Now you might think, well, if I'm looking for a service in Asia, let's say in Mumbai, and if it is not available, why not simply switch to North Virginia and start using it? You could, but that's going to add more latency to your application. So that's why we need to check for application which is check for region, which is very near to the place where you want to serve your customers, and find nearest region instead of always going back to North Virginia and deploying your application in North Virginia. Again, there's a place, there's a link in aws.com that you can go and look for services available in different region, and that's exactly what you're seeing here. And if your service is not available in a particular region, switch to the other region that provides your service, the nearest other region that provides that service, and start using service from there. With the coming up of cloud, a lot of companies have turned down their monitoring team. Instead, they want to go with the monitorings that cloud provides. Nobody wants to, or at least many people don't want to go through the hassle of at least new startups and new companies that are thinking of having a monitoring environment. Now, they don't want to go with traditional NOC monitoring. Instead, they would like to leverage AWS monitorings available, because it monitors a lot of stuff, not just the availability, but it monitors a lot of stuff like failures, errors. It also triggers emails, stuff like that. So how do you actually set up a monitor to website? How do you set up a monitor to monitor the website metrics in real time in AWS? The simple way, anytime you have a question about monitoring, CloudWatch should strike your mind, because CloudWatch is meant for monitoring, is meant for collecting metrics, is meant for providing graphical representation of what's going on in a particular network at a particular point of time. So CloudWatch helps us to monitor applications, and using CloudWatch we can monitor the state changes, not only the state changes, the auto-scaling life cycle events. Anytime there are more services added, there is a reduction in the number of servers because of less usage. Very informative messages can be received through CloudWatch. CloudWatch can now support scheduled events. If you want to schedule anything, CloudWatch has an event that would schedule an action, right? Schedule a trigger, time-based, not incident-based. Anything happening and then you get an action happening that's incident-based. On the other hand, you can simply schedule few things on time-based. So that's possible with CloudWatch. So this CloudWatch integrates very well with a lot of other services like notifications for notifying the user or for notifying the administrator about it. And it can integrate well with Lambda. So to trigger an action, anytime you're designing an auto-healing environment, this CloudWatch can actually monitor and send an email if we are integrating it with SNS, Simple Notification Service. Or this CloudWatch can monitor, and based on what's happening, it can trigger an event in Lambda, and that would in turn run a function till the environment comes back to normal. So CloudWatch integrates well with a lot of other AWS services. Alright, so CloudWatch has 3 statuses: green when everything is going good, yellow when the service is degraded, and red when the service is not available. Green is good, so we don't have to do anything about it. But anytime there's an yellow, the picture that we're looking at, it's actually calling a Lambda function to debug the application and to fix it. And anytime there's a red alert, it immediately notifies the owner of the application about, well, the service is down, and here is the report that I have. Here is the metrics that I've collected about the service, stuff like that. If the job role requires you to manage the servers as well, there are certain job roles which are on the system side. There are certain job roles which is development plus system side. Now you're responsible for the application and the server as well. So if that's the case, you might be tested with some basic questions like the different types of virtualization in AWS and what are the difference between them. Alright, the 3 major types of virtualization are HVM, which is hardware virtual machine. The other one is PV, para virtualization. And the third one is PV on HVM, para virtualization on hardware virtual module. Alright, the difference between them, or actually describing them, is actually the difference between them. HVM, it's actually a fully virtualized hardware. The whole hardware is virtualized and all virtual machines act separate from each other. And these VMs are booted by executing master boot record in the root block. And when we talk about para virtualization, Paragrub is actually the special boot loader which boots the PV AMIs. And when we talk about PV on HVM, it's actually the marriage between HVM and PV. And this para-virtualization on HVM, in other words, PV on HVM, it actually helps operating system take advantage in storage and the network input output available through the host. Another good question is, name some of the services that are not region specific. Now, you've been taught that all services are within a region and some services are within an availability zone. For example, EC2 is within an availability zone, EBS is within an availability zone, S3 is region specific, DynamoDB is region specific, stuff like that. VPC is both availability and region specific, meaning subnets are availability zone specific and VPC is region specific, stuff like that. So you might have thought, you might have learned in that combination. But there could be some tricky questions that tests you how well you have understood the region, non-region, and availability, non-availability services. I should say there are services that are not region specific. That would be IAM. So we can't have IAM for every availability zone and for every region, which means users will have to use one username and password for one region, and anytime they switch to another region they will have to use another username and password. That's more work, and that's not a good design as well. Authentication has to be global. So IAM is a global service, and which means it's not region specific. On the other hand, Route 53 is again a regional specific, so we can't have Route 53 for every region. Route 53 is not a region specific service. It's a global service, and it's one application. Users access from everywhere or from every part of the world, so we can't have one URL or one DNS name for each region if your application is a global application. And then Web Application Firewall works well with CloudFront. Then CloudFront is a region-based service. So the Web Application Firewall, it's not a region-specific service. It's a global service. And CloudFront is again a global service. Though you can cache content on a continent and country basis, it's still considered a global service. Right? It's not bound to any region. So when you activate CloudFront, you're activating it away from region or availability zone. So when you're activating a Web Application Firewall, because it's not a region specific service, you're activating it away from availability zone and regions. So a quick recap: IAM users, groups, roles, and accounts, they are global services. They can be used globally. Route 53 services are offered at edge locations and they are global as well. Web Application Firewall, a service that protects our web application from common web exploits. They are global service as well. CloudFront is Global Content Delivery Network, CDN, and they are offered at edge locations, which are a global service. In other words, non-region specific service or beyond region service. Alright, this is another good question as well. In the project that you are being interviewed, if they really want to secure their environment using NAT, or if they are already securing their environment using NAT by any of these two methods like NAT gateway or NAT instances, you can expect this question: what are the difference between a NAT gateway and NAT instances? Now, they both serve the same thing, right? So they're not two different services trying to achieve two different things. They both serve the same thing, but still they do have differences in them. Right? On a high level, they both achieve providing NATing for the service behind it, but the difference comes when we talk about the availability of it. NAT gateway is a managed service by Amazon, whereas NAT instance is managed by us. Now I'm talking about the third point, maintenance here. NAT gateway is managed by Amazon, NAT instance is managed by us, and availability of NAT gateway is very high and availability of NAT instance is less compared to the NAT gateway because it's managed by us. It's on an EC2 instance which could actually fail, and if it fails we'll have to relaunch it. But if it is NAT gateway, if something happens to that service, Amazon would take care of reprovisioning it. And talking about bandwidth, it can burst up to 75 gigabits. Traffic through the NAT gateway can burst up to 75 gigabits. But for NAT instance, it actually depends on the server that we launch. And if we are launching a T2 micro, it barely gets any bandwidth. So there's a difference there. And the performance, because it's highly available because of the bigger pipe, 75 gigabits, the performance of the NAT gateway is very high, but the performance of the NAT instance is going to be average. Again, it depends on the size of the NAT instance that we pick. And billing. A billing for NAT gateway is the number of gateways that we provision and the duration for which we use the NAT gateway. But billing for NAT instance is number of instance and the type of instance that we use. Of course, number of instance, duration, and the type of instance that we use. Security in NAT gateway cannot be assigned, meaning it already comes with full packed security. But a NAT instance, security is a bit customizable. I can go and change the security because it's a server managed by me or managed by us. I can always change the security. Well, allow this, don't allow this, stuff like that. Size and load of the NAT gateway is uniform, but the size and the load of the NAT instance changes as per a NAT gateway is a fixed product. But NAT instance can be small instance, can be a big instance, so the size and the load through it varies. Right. The other question you could get asked is, what are the difference between stopping and terminating an EC2 instance? Now you will be able to answer only if you have worked on environments where you have your instance stopped and where you have your instance terminated. If you have only used Collab and are attending the interview, chances are that your way is lost when answering this question. It might look like both are the same. Well, stopping and terminating, both are the same. But there is a difference in it. So when you stop an instance, it actually performs a normal shutdown on the instance and it simply moves the instance to the stopped state. But when you actually terminate the instance is moved to the stop state. The EBS volumes that are attached to it are deleted and removed, and we'll never be able to recover them again. So that's a big difference between stopping and terminating an instance. If you're thinking of using the instance again along with the data in it, you should only be thinking of stopping the instance, but you should be terminating the instance only if you want to get rid of that instance forever. If you are being interviewed for an architect level position or a junior architect level position or even an cloud consultant level position or even in an engineering position, this is a very common question that get asked. What are the different types of EC2 instances based on their cost or based on how we pay them, right? They're all compute capacity. For example, the different types are on-demand instances, spot instances, and reserved instances. It kind of looks the same. They all provide the compute capacity. They all provide the same type of hardwares for us. But if you're looking at cost saving or optimizing cost in our environment, we got to be very careful about which one are we picking. Now we might think that, well, I'll go with on-demand instance because I pay on a per hour basis, which is cheap. I can use them anytime I want, and anytime I don't want, I can simply get rid of it by terminating it. You're right, but if the requirement is to use the service for 1 year, the requirement is to use the service for 3 years, then you'll be wasting a lot of money buying on-demand instances. You'll be wasting a lot of money paying on an hourly basis. Instead, we should be going for reserved instance where we can reserve the capacity for the complete 1 year or complete 3 years and save huge amount in buying reserved instances. Alright, so on-demand is cheap to start with if you're only planning to use it for a short while, but if you're planning to run it for a long while, then we should be going for reserved instance. That is what is cost efficient. So spot instance is cheaper than on-demand instance. And there are different use cases for spot instance as well. So let's look at one after the other. The on-demand instance. The on-demand instance is purchased at a fixed rate per hour. This is very short-term and irregular workloads. And for testing, for development, on-demand instance is a very good use case. We should be using on-demand for production. Spot instance. Spot instance allows users to purchase EC2 at a reduced price, and anytime we have more instances, we can always go and sell it in spot instances. I'm referring to anytime we have more reserved instances, we can always sell them in spot instance catalog. And the way we buy spot instance is we actually put a budget. This is how much I'm willing to pay. All right, would you be able to give service within this cost? So anytime the price comes down and meets the cost that we have put in, we'll be assigned an instance. And anytime the price shoots up, the instance will be taken away from us. But in case of on-demand instances, we have bought that instance for that particular hour and it stays with us. But with spot instances, it varies based on the price. If you meet the price, you get the instance. If you don't meet the price, it goes away to somebody else. And the spot instance availability is actually based on supply and demand in the market. There's no guarantee that you will get spot instance at all time. Alright, so that's a caveat there you should be familiar with. That's a caveat there you should be aware when you are proposing somebody that we can go for spot instance and save money. It's not always going to be available. If you want your spot instance to be available to you, then we need to carefully watch the history of the price of the spot instance. Now, how much was it last month and how much is it this month? So how can I quote, or how much can I quote, stuff like that. So you got to look at those history before you propose somebody that, well, we're going to save money using spot instance. On the other hand, reserved instance provide cost savings for the company. We can opt for reserved instances for 1 year or 3 years. There are actually 3 types of reserved instances: light, medium, and heavy reserved instances. They are based on the amount that we would be paying. And cost benefit also depends with reserved instance. The cost benefit also depends based on, are we doing all upfront or no upfront or partial payment, then split the rest as monthly payments. So there are many purchase options available. But overall, if you're looking at using an application for the next 1 year and 3 years, you should not be going for on-demand instance. You should be going for reserved instance, and that's what gives you the cost benefit. And in an AWS interview, sometimes you might be asked, how you interact with the AWS environment. Are you using CLI? Are you using console? And depending on your answer, whether console or CLI, the panelists put a score. Okay, this person is CLI specific, this person is console specific, or this person has used AWS environment through the SDK, stuff like that. So this question tests whether you are a CLI person or a console person. And the question goes like this: how do you set up SSH agent forwarding so that you do not have to copy the key every time you log in? If you have used PuTTY, anytime if you want to log into an EC2 instance, you will have to put the IP and the port number. Along with that, you will have to map, or we will have to map the key in the PuTTY, and this has to be done every time. That's what we would have done in our lab environments, right? But in production environment, using the same key or mapping the same key again and again every time, it's actually an hassle. It's considered as a blocker. So you might want to cache it. You might want to permanently add it in your PuTTY session so you can immediately log in and start using it. So here in the place where you would actually map the private key, there's a quick button that actually fixes or that actually binds your SSH to your PuTTY instance. So we can enable SSH agent forwarding that will actually bind our key to the SSH, and next time when we try to log in, we don't have to always go through mapping the key and trying to log in. Alright, this question, what are Solaris and AX operating systems? Are they available with AWS? That question generally gets asked to test how familiar are you with the AMIs available? How familiar are you with EC2? How familiar are you with the EC2 hardwares available? That basically tests that. Now the first question or the first thought that comes to your mind is, well, everything is available with AWS. I've seen Windows, I've seen Ubuntu, I've seen Red Hat, I've seen Amazon AMIs, and if I don't see my operating system there, I can always go to Marketplace and try them. If I don't find a Marketplace, I can always go to Community and try them. So there are a lot of AMIs available, there are a lot of operating systems available. I will be able to find Solaris and AX, but that's not the case. Solaris and AX are not available with AWS. That's because Solaris uses a different Solaris does not support the architecture, does not support public cloud currently. The same goes for AX as well. They run on Power CPU and not on Intel, and as of now, Amazon does not provide power machines. This should not be confused with HPC, which is high performance computing. Should not be confused with that. Now these are different hardwares, different CPU itself that the cloud providers do not provide yet. Another question you could get asked in organizations that would want to automate their infrastructure using Amazon native services would be, how do you actually recover an EC2 instance or auto recover an EC2 instance when it fails? Well, we know that EC2 instances are considered as immutable, meaning irreparable. We don't spend time fixing bugs in an OS, stuff like that. Once an EC2 instance crashes, like it goes on a OS panic, or there are various reasons why it would fail. So we don't have to really worry about fixing it. We can always relaunch that instance and that would fix it. But what if it happens at 2 o'clock in the night? What if it happens during a weekend when nobody's in office looking or monitoring those instances? So you would want to automate that, not only on a weekend or during midnights, but it's general practice good to automate it. So you could face this question: how do you actually automate an EC2 instance once it fails? And the answer to that question is using CloudWatch, we can recover the instance. So as you see, there is an alarm threshold set in CloudWatch. And once the threshold is met, meaning if there is an error, if there is a failure, if the EC2 instance is not responding for a certain while, we can set an alarm. And once the alarm is met, let's say the CPU utilization stayed high for 5 minutes. Right, it's not taking any new connections, or the instance is not pinging for 5 minutes, or in this case it's 2 minutes. It's not pinging, so it's not going to respond connection. So in those cases, you would want to automatically recover that EC2 instance by rebooting the instance. All right, now look at this, the take this action section under the action. So there we have a bunch of options like recover this instance, meaning reboot the instance. So that's how we would recover. The other two options are beyond the scope of the question, but still you can go ahead and apply, just like I'm going to do it. So the other option is stop the instance. That's very useful when you want to stop instances that are having low utilizations. Nobody's using the system as of now. You don't want them to be running and wasting the cloud expenditure. So you can actually set an alarm that stops the EC2 instance that's having low utilization. So somebody was working in an instance and they left it without, or they forgot to shut down that instance, and it gets, they will only use it again the next day morning. So in between there could be like 12 hours that the system is running idle, nobody's using it, and you're paying for it. So you can identify such instances and actually stop them when the CPU utilization is low, meaning nobody is using it. The other one is to terminate. Let's say you want to give system to somebody temporarily and you don't want them to hand the system back to you. All right, this is actually an idea. In other words, this is actually the scenario. So you hand over a system to somebody, and when they're done, they're done. We can actually terminate the system. So you could instruct the other person to terminate the system when they're done, and they could forget and the instance could be running forever. Or you can monitor the system after the specified time is over and you can terminate the system. Or best part, you can automate the system termination. So you assign a system to somebody and then turn on this CloudWatch action to terminate the instance when the CPU is low for like 2 hours, meaning they've already left, or CPU is low for 30 minutes, meaning they've already left, stuff like that. So that's possible. And if you're getting hired for an system side architect, or even on the sysops side, you could face this question: what are the common and different types of AMI designs? There are a lot of AMI designs. The question is the common ones and the difference between them. So the common ones are the full back AMIs, and the other one is just enough OS AMI, JE OS AMI, and the other one is hybrid type AMIs. So let's look at the difference between them. The full backed AMI, just like the name says, it's fully baked. It's ready to use AMI. This is the simplest AMI to deploy. It can be a bit expensive, it can be a bit cumbersome because you'll have to do a lot of work beforehand. You could use the AMI. So a lot of planning, a lot of thought process will go into it, and the AMI is ready to use, right? You hand over the AMI to somebody and it's ready to use, or if you want to reuse the AMI, it's already ready for you to use. So that's full baked AMI. The other one is just enough operating system AMI. Just like the name says, it has, as you can also see in the diagram or in the picture, it covers a part of the OS. All bootstraps are already packed properly, and the security monitoring, logging, and the other stuff are configured at the time of deployment or at the time you would be using it. So not much thought process will go in here. The only focus is on choosing the operating system and what goes, the operating system specific agents or bootstraps that goes into the operating system. That's all we worry about. The advantage of this is it's flexible, meaning you can choose to install additional softwares at the time of deploying, but that's going to require an additional expertise on the person who will be using the AMI. So that's another overhead there. But the advantage is that it's kind of flexible. I can change the configurations during the time of deployment. The other one is a hybrid AMI. Now the hybrid AMI actually falls in between the fully baked AMI and just enough operating system options. So these AMIs have some features of the baked type and some features of the just enough OS type. So as you see, the security, monitoring, logging are packed in that AMI, and the runtime environments are installed during the time of a deployment. So this is where the strict company policies would go into the AMI. Company policies like you got to log this, you got to monitor this. These are the ports that generally gets open in all the systems, stuff like that. So they strictly go into the AMI and sits in an AMI format. And during deployment, you have the flexibility of choosing the different runtime and the application that sits in an EC2 instance. Another very famous question you would face in an interview is, how can you recover login to an EC2 instance to which you lost the key? Well, we know that if the key is lost, we can't recover it. There are some organizations that integrate their EC2 instances with an AD. That's different. Alright, so you can go and reset the password in the AD and you will be able to log in with the new password. But here the specific tricky question is, you are using a key to log in, and how do you recover if you have lost the key? Generally, companies would have made a backup of the key so we can pick from the backup, but here the specific question is, we have lost the key, literally no backups on the key at all. So how can we log in? And we know that we can't log into the instance without the key present with us. So the steps to recover is that make the instance use another key and use that key to log in. Once the key is lost, it's lost forever. We won't be able to recover it. You can't raise a ticket with Amazon. Not possible. They're not going to help. It's beyond the scope. So make the instance use another key. It's only the key that's the problem. You still have valid data in it. You got to recover the data. It's just the key that's having the problem. So we can actually focus on the key part alone and change the key, and that will allow us to log in. So how do we do it? Step-by-step procedure. So first, verify the EC2 config service is running in that instance. If you want, you can actually beforehand install the EC2 config in that service, or you can actually make the EC2 config run through the console. Just a couple of button clicks and that'll make the EC2 config run in that EC2 instance, and then detach the root volume for that instance. Of course, it's going to require a stop and start. So detach the root volume from the instance, attach the root volume to another instance as a temporary volume, or it could be a temporary instance that you've launched only to fix this issue, and then log in to that instance and to that particular volume and modify the configuration file. Modify it to use the new key, and then move the root volume back to its original position and restart the instance. And now the instance is going to have the new key, and you also have the new key with which you can log in. So that's how we go ahead and fix it. Now let's move on to some product specific or S3 product specific questions. A general perception is S3 and EBS can be used interchangeably, and the interviewer would want to test your knowledge on S3 and EBS. Well, EBS uses S3, that's true, but they can't be interchangeably used. So you might face this question, what are some key differences between AWS S3 and EBS? Well, the differences are, S3 is an object store, meaning you can't install anything in it. You can store drive files, but you can't actually install in it. It's not a file system. But EBS is a file system. You can install services, install applications in it, and that's going to run stuff like that. And talking about performance, S3 is much faster and EBS is super faster when accessing from the instance, because from the instance, if you need to access S3, you'll actually have to go out through the internet and access the S3, or S3 is an external service, a very external service. You'll have to go through, or you'll have to go outside of your VPC to access S3. S3 does not come under a VPC, but EBS comes under a VPC. It's on the same VPC, so you would be able to use it kind of locally. Compared to S3, EBS is very local, so that way it's going to be faster. And redundancy, talking about redundancy of S3 and EBS. S3 is replicated. The data in S3 is replicated across the data centers, but EBS is replicated within the data center, meaning S3 is replicated across availability zones. EBS is within an availability zone. So that way redundancy is a bit less in EBS. In other words, redundancy is higher in S3 than EBS. And talking about security of S3, S3 can be made private as well as public, meaning anybody can access S3 from anywhere in the internet. That's possible with S3. But EBS can only be accessed when attached to an EC2 instance. Right, just one instance can access it, whereas S3 is publicly directly accessible. The other question related to S3 security is, how do you allow access to a user to a certain bucket, which means this user is not having access to S3 at all, but this user needs to be given access to a certain bucket. How do we do it? The same case applies to servers as well. In few cases, there could be an instance where a person is new to the team and you actually don't want them to access the production service. Now he is in the production group and by default he or she is granted access to that server, but you specifically want to deny access to that production server till the time he or she is matured enough to access or understand the process, understand the do's and don'ts before they can put their hands on the production server. So how do we go about doing it? So first we would categorize our instances. Well, these are critical instances. These are normal instances. And we would actually put a tag on them. That's how we categorize, right? So you put a tag on them. Put a tag saying, well, they are highly critical, they are medium critical, and they are not critical at all. Still, they're in production, stuff like that. And then you would pick the users who wants to or who should be or should not be given access to a certain server. And you would actually allow the user to access or not access servers based on a specific tag. In other words, you can use actually tags. In the previous step, we put tags on the critical server, right? So you would define that this user is not going to use this tag. All right, this user is not allowed to use the resources with this tag. So that's how you would make your step forward. So you would allow or deny based on the tags that you have put. So in this case, he or she will not be allowed to servers which are tag critical servers. So that's how you deny access to them. And the same goes for bucket as well. If an organization is excessively using S3 for their data storage because of the benefit that it provides, the cost and the durability, you might get asked this question, which is organizations would replicate the data from one region to another region for additional data durability and for having data redundancy. Not only for that, they would also do that for DR purposes, for disaster recovery. If the whole region is down, you still have the data available somewhere else and you can pick and use it. Some organizations would store data in different regions for compliance reasons, to provide low latency access to their users who are local to that region, stuff like that. So when companies do replication, how do you make sure that there is consistency in the replication? How do you make sure that the replication is not failing and the data gets transferred for sure and there are logs for that replication? This is something that the companies would use where they're excessively using S3 and they're fully relying on the replication in running their business. And the way we could do it is we can set up a replication monitor. It's actually a set of tools that we could use together to make sure that the cloud replication, region level replication is happening properly. So this is how it happens. Now on this side, on the left hand side, we have the region 1 and on the right hand side we have region 2, and region 1 is the source bucket and region 2 is the destination bucket. Right, so object is put in the source bucket and it has to go directly to the region 2 bucket or made a copy in the region 2 bucket. And the problem is sometimes it fails and there is no consistency between them. So the way you would do it is connect these services together and create an cross replication or cross region replication monitor that actually monitors your environment. So there are cloud watch that make sure that the data is moved, no data is failing. Again, there's cloud watch on the other end, make sure that the data is moving. And then we have the logs generated through CloudTrail, and that's actually written in DynamoDB. And if there is an error, if something is failing, you get notified through an SMS or you get notified through an email using the SNS service. So that's how we could leverage these tools and set up an cross-region replication monitor that actually monitors your data replication. Some common issues that companies face in VPC is that we all know that I can use Route 53 to resolve an IP address externally from the internet, but by default the servers won't connect to the other servers using our custom DNS name. That it does not do that by default. So it's actually a problem. There are some additional things that as an administrator or as an architect or as a person who uses it, you will have to do. And that's what we're going to discuss. So the question could be, VPC is not resolving the server through the DNS. You can access it through the IP, but not through the DNS name. And what could be the issue and how do you go about fixing it? And you will be able to answer this question only if you have done it already. It's a quick and simple step. By default, VPC does not allow, that's the default feature, and we will have to enable the DNS hostname resolution before. Now this is for the custom DNS, not for the default DNS that comes along. This is for the custom DNS. So we will have to enable the DNS hostname resolution. So we'll have to enable the DNS hostname resolution so they actually resolve. Let's say I want to connect to server1.simplylearn.com. By default, it's not allowed. But if I enable this option, then I will be able to connect to server1.simplylearn.com. If a company has VPCs in different regions and they have a head office in a central place and the rest of them are branch offices and they are connecting to the head office for access or for saving data or for accessing certain files or certain data or storing data, all right, so they would actually mimic the hub and spoke topology where you have the VPC which is centrally in an accessible region, a centrally accessible region, and then you would have a local VPCs or branch offices in different other regions, and they get connected to the VPC in the central location. And the question is, how do you actually connect the multiple sites to a VPC and make communication happen between them? By default, it does not do that. We know that VPCs, they need to be peered between them in order to access the resources. Let's look at this picture, right? So I have like a customer network or branch offices in different parts and they get connected to a VPC. That's fine. So what we have achieved is those different offices, the remote offices, they are connecting to the VPC and they're talking, but they can't connect or they can't talk to each other. That's what we have built. But the requirement is the traffic needs to, or they should be able to talk to each other, but they should not have a direct connection between them, which means that they will have to come and hit the VPC and then reach the other customer network, which is in Los Angeles or which is in New York. All right, that's the requirement. So that's possible with some architecting in the cloud. So that's using VPN Cloud Hub. You look at these dotted lines, which actually allows customers or which actually allows the corporate networks to talk to each other through the VPC. Again, by default, it doesn't happen. Cloud Hub is an architecture that we should be using to make this happen. And what's the advantage of it? As a central office or as the headquarters office, which is in the VPC, or headquarters data center, which is in the VPC, you have control, or the VPC has control on who talks to who and what traffic can talk to, what traffic can be routed to the other head office, stuff like that. That centralized control is on the VPC. The other question you could get asked is, name and explain some security products and features available in VPC. Well, VPC itself is an security service. It provides security service to the application, but how do you actually secure the VPC itself? That's the question. And yes, there are products that can actually secure the VPC, or the VPC delivers those products to secure the application. Access to the VPC is restricted through a network access control list. All right, so that's an security product in VPC. And a VPC has security groups that protects the instances from unwanted inbound and outbound traffic, and network access control list protects the subnets from unwanted inbound and outbound access. And there are flow logs we can capture in VPC that captures incoming and outgoing traffic through a VPC, which will be used for later analysis, as in what's the traffic pattern, what's the behavior of the traffic pattern, stuff like that. So there are some security products and features available in VPC. Now, how do you monitor a VPC? VPC is a very important concept, very important service as well. Everything sits in a VPC. Most of the service sits in a VPC, except for Lambda and S3 and DynamoDB and a couple of other services. Most of them sit in a VPC for security reasons. So how do you monitor your VPC? How do you gain some visibility on your VPC? Well, we can gain visibility on our VPC using VPC flow log. That's the basic service. As you see, it actually captures what's allowed, what's not allowed, stuff like that. Which IP is allowed, which IP is not allowed, stuff like that. So we can gather it and we can use that for analysis. And the other one is CloudWatch and CloudWatch logs, the data transfers that happen. So this is who gets allowed and who does not get allowed. I mean, the flow logs is who is allowed and who's not allowed, that kind of detail. And CloudWatch gives information about the data transfer, how much data is getting transferred. We can actually pick unusual data transfers if there is a sudden hike in the graph. There's a sudden hike and something happens at 12 on a regular basis and you weren't expecting it. There's something suspicious. It could be valid backups. It could be malicious activity as well. So that's how you know, by looking at CloudWatch logs and CloudWatch dashboard.
As we wrap up our cloud computing course, it's time to reflect on what you have learned. You now have a solid understanding of cloud technology and how it can transform businesses and careers. Remember, the cloud is always evolving, so staying informed about the latest trends and advancements will be important. We encourage you to continue exploring and applying your knowledge. Thank you for being a part of this course, and we wish you success as you venture into the world of cloud computing. The sky is not the limit. The cloud is your gateway to endless possibilities.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.